Hi, and welcome everyone to Dask Me Anything about data analytics at scale. This tutorial will be given by Ramon Perez, and my name is James. I'll be hanging out in the chat to answer any questions you may have. And I think that's it for intros. At this point, I'll kind of hand it over to Ramon to handle everything else. Ramon.
Awesome. Welcome, everyone. Good morning, good afternoon, good evening, whatever you are around the world. I am in Sydney. So right now, for me, it is exactly 5 a.m. So good morning to those in this side of the hemisphere. And yeah, welcome. Very excited to bring this tutorial to all of you. So let's go ahead and dive right in. So the first thing that you should have access to is the link to the repo. So if you have already gotten all set up, then awesome. If not, then the link is available in the chat. And go over to that link. Make sure you either download the tutorial at the top with the download zip folder. And then at the bottom, there are some instructions on how to get set up. If your computer is not, if you don't rather not run the tutorial in your computer, there are ways for you to go over the tutorial on your own in an isolated environment. The isolated environment is called Binder. And if you go to this little link in the repo and you click Launch Binder, then it will take you, or it should take you, let's see. Okay, now it should take you to a session where you're going to be in an isolated environment and you can run this and it will not be using the exact same resources in your computer. So this is great if you don't have a great connection or whatnot, and you don't want things to slow down your computer. Now, another option is that you will have in every single one of the notebooks is that you can have you can just work with a subsample of the data set that we're going to be using today. So make sure that if you have that option as well, so you don't have to use the full data set. That way your computer doesn't slow down a little bit, because we're going to be working with quite a bit of data. So actually, let me travel back into the repo. Okay, so then the next thing is that you should have, if you have not downloaded the dataset yet, please go ahead and do so. The data is going to be all the way at the bottom in the section called data. And if you see the link, it's called link to the data. And it's going to send you to something called a treasure, which is just another cloud provider. And it's called Treasure It. I have put the files in a folder called SciPy US 21. And there are two folders that you will need. One is the external, one is the final. The final one has the entire data set that we'll be using. It has about 40 Parquet files. So if you don't have to worry about downloading each one of those. If you go to the main folder, you can click at the top, download all, and it will download all of the files in your in these two folders. Make sure you put those in your directory where you have Dask, where you have the tutorial at, where you downloaded the files for the tutorial at. Okay, so with that said, let me tell you, before I tell you how the tutorial is going to run, let me go ahead and tell you very quickly a little bit about myself. So yes, my name is Ramon. I work at a place called Coder Academy in Sydney, and I am a data scientist and instructor there. I teach courses in data analytics, and for the past year, I've been working on, or for the last 2 years, I've been working on developing a data science program. So that is what I do here. Before that, I used to live in Washington, D.C. I worked as a researcher there, and before that, I was in Kansas City. All right, so that's a little bit about me. Let's talk about how the tutorial is going to run. So here I have a somewhat budgeted amount of time for the tutorial. It says 3.5 hours of hands-on coding, and then the other half an hour is sort of split in between the breaks across the tutorial. At the very beginning, I put here that I was going to have a little presentation. I have added everything I wanted to say in a presentation to the notebooks. So we're gonna walk through those things within the notebooks. Explanations for what a regression is, explanation to what a t-test is, explanation to how to build a dashboard, and explanations on how to do exploratory data analysis. We're gonna walk through all of that throughout the notebooks. Then I'm going to do a quick intro to that. There is no notebook there because I'll do it live. And then we're going to have a 10-minute break. Then we're going to go into exploratory data analysis. There's about 30, including the exercises, there's about 30 or 40 questions in that notebook that hopefully we get through as many as we can. I'm going to try to budget it or keep it down to an hour just so that we can go through all of the notebooks. There's a lot of material to go over. Now here I put in the second one that we were going to do the hypothesis testing, which I now call statistical programming, because there's 3 things, and there's even a little app that we're building in it. I put it as the second one. I'm going to leave that one to the third one, and then we're going to jump into dashboards in our second notebook. So that's the way it's going to run. There's about.
Well, if you have a second, sorry to interrupt you. There's a few questions in the both of the chat and Q&A sections about setup. And if you're going to talk about this in just a second, tell me to be quiet. But there's this link to the data link later on in the README. There's actually there's an external and a final folder there. The question was, which one do we download, external or final, or do we need both?
Yeah, you will need both. And great question. Yeah, you will need both. So make sure that at the top, you click on download all, and then, download the entire folder, both data files, because you will need them both.
Great. Then there's one other question about, related to that. If they are opting to use the binder option, how should they download the data onto the binder instances?
That's a great question. So when you go to binder, let me make it a little bit bigger. When you go to binder, you're going to have at the top an upload button. And then in that upload button, you can go to your, let's see, tutorials, SciPy. Then you could go straight to where the data is at, and then upload external, upload final, and so forth. I believe it will take you a bit of time to upload those. So what you want to make sure is that once you upload those into Binder, you keep them there, or you don't let the Binder session go inactive after 10 minutes. So Binder usually times out after 10 minutes of inactivity. So what you want to do is, if you open a notebook, say for example, you go to number 1 EDA, and then a couple of minutes have passed, 5, 6, 7 minutes, make sure you come back and run a cell. So like reload the packages, or go ahead and add a new cell and do a print hello something. But make sure you keep Binder alive. So and don't let it go over 10 minutes. But yeah, you will have to upload the files into Binder using the upload button at the top. It says unable to download, unable to download.
Yeah,
How long does it take?
Yeah.
I got unable to download as well. It's been about 2 minutes for me, and it's been zipped. Unable to download. Binder works fine. It failed for me too. Okay, so let's see. I even got unable to download as well. Okay, so let me check if I can have something different to share it.
Daniel commented, downloading external and final individually worked for me. So I'm going to give that a shot too to see if that helps.
What was it that Daniel tried? He tried to do downloading external and final. Okay, individually work better. Okay, perfect. So let's see. So if I just click download this one, final first. I'm also going to try and put it in Google Drive to see if maybe an open link to that works better. Okay, so right now I am uploading. I don't know if you can see my other screen or you can just see the one where I have the treasure it.
Still
But
just see the
treasure it. Okay, okay. So I am trying to now put the files in Google Drive and to see if that might work better. And bear with me for a second, please. And final. Okay, so I uploaded, right now is at 2 out of 43. So right now is uploading to Google Drive. And so then there's another open link that I just share in the chat that you can use to download the files. So the only caveat is that the bigger files, the ones that we're going to start working with very soon, those are still uploading. Right now it says there's the external one is already available in that link that I just sent everyone. But then the second one, the one for final, only has about 3 files so far. So what I'm gonna go ahead and do, I'm gonna stop or not stop. I'm gonna continue talking about the tutorial. I'm gonna jump into the first notebook where we're just going to talk about DAsk and how it works and a couple of things that we should keep in mind. And then hopefully by the time we finish with that, where we don't need any data files yet, then the files will have been uploaded and everybody will have the files in their computers. Yes, the folder is the final one is about 1.8 gigs compressed. And then the other one, I think it is about 400 megabytes or something like that. It might be a little bit more than that. All right, so let's go ahead and jump in to talk a little bit about DAsk. So we're going to do it in an interactive way. By the way, I should go ahead and say, or let me actually finish with the repo. So I'm hoping that all of you have a bit of experience with Python. Can anybody tell me yeah, I love these emojis. If you have ever used Pandas before. Okay, a lot of people have used Pandas. Have you used, oh, I love it. Have you used, of course, you probably used Nunpai before. Have anyone here used HoloViews or Dask before? I'm loving all of these emojis in the screen. This is incredible. Awesome, awesome, awesome. All right, so this is going to be a very fast and easy introduction. Okay, can anyone tell me in the chat if you have not used Pandas before, or can you put some sort of emoji if you have never used Pandas before, or maybe not an emoji, maybe put in the chat me or oh, there are the polls. Ah, create a poll. Okay. Have you used? Oh, this is very cool. Have you used Pandas before? Yes. No. Allow multiple show results to everyone. All right, so I think I just published a poll. Okay, or I'm about to publish. Okay, can everybody see that poll? successfully published. Okay. Awesome. All right. So quite a few of you have used Pandas. Okay. So we will give it a quick introduction. And so now the goals and the learning outcomes of the tutorial is to get you to learn how to do data analysis with large amounts of data in your computer. This is not necessarily not necessarily. This is not an ins and out tutorial of DAsk. For that, you have James here in the chat. He is the master or one of the masters of DAsk, and he really knows DAsk very, very well. I don't, and I don't claim to know the ins and outs of it, but I've used it quite a bit in my work to do large-scale data analysis with data that doesn't fit into memory. Right now, the data set that you're downloading is compressed in a way that I believe is 1/3 of the actual size. So all in all, uncompressed, it's about I think it's about 5 to 6 gigs. And so it's a fairly good size. And even if you try to put all of that into Pandas, it will actually not work that well. So the goal for this is to get you a little bit more comfortable to think about how lazy computations work, how to build a computational graph with Dask, and then build your analysis step by step. So that's the goal for the tutorial. All right, so let's go ahead and get started for everyone that knows Pandas. This should be a very quick and easy refresher. And for those of you who are new to it, then yeah, this will be a quick introduction to Pandas and Nunpai. So let's open up a Jupyter notebook. I love the Untitled one, so I tried to name them immediately after I created them. So I'm going to put it 00, and I'm going to say this one is Flash Intro. And what we are going to do is, let me see where okay. So the ones in Google Drive are halfway there. So hopefully by the time we finish this, it should all be up there. So let me zoom in a little bit. So usually for those of you who have never used Pandas before, Pandas we usually import it with an alias of PD. And usually when we use Pandas, we're very likely to import Numpy as well to work with it and generate random data or just also use some of the nice functionality that it offers. Pandas is a tool built on top of Numpy, and then Dask uses Pandas to parallelize the data frames that you get to create with Pandas. So you can think of Nunpai as working with the n-dimensional data, and then you can think about Pandas as working with a spreadsheet in Python. So Numpy, we usually import it as NP. And one of the cool things that you can do with Numpy is that you can start generating random data. And we're going to create an array. And we're going to create it with random numbers. If you have not used Jupyter Notebooks before, you have the great functionality that you can press tab every time you're adding or using a method or creating a method, and it provides you with tab completion. Even if you don't know what you want to write, if you put a dot in front of it and then you press the tab, then it will give you a lot of choices that you might be able to pick from. So the one we're gonna pick is the run. And if you want to see what's inside of that function, you can also press Shift Tab once you're inside the parentheses, and then it will give you a description, the doc string, essentially of that method. So here we have that rand will generate random values given a shape, and we can pass in a shape. We can either give it 100 numbers, and then it will generate 100 numbers for us. We can give it a particular shape, we can reshape it however we like, and we can say, okay, we want this to have 20 rows and 4 columns. And I believe it's without the, oh, sorry, 20 by 5. There you go. So now we have 5 columns, a gridded data set, and 20 rows. And the way in which you see Nunpai is not essentially in the same way in which you see Pandas. The way in which you see Pandas is sort of the same way in which you would see a spreadsheet. So say we want to create a data frame, and we're going to call that data frame df. We can use Pandas data frame constructor, and to it, we can pass a data, which will be an ND array, which is exactly what our NumPy array is now. So we can use the data, and we can also pass it a couple of columns. And for those column names, we can use a list of, we're just going to use a list of letters to make it very simple for us. So A, B, C, D, and E. And the result of that is a nice data frame that looks just like the one that you will see in a spreadsheet. Once we have a data frame, we can add columns to it in the same way in which you add a key, a new key to a dictionary in plain Python. So I can say my new call, and then I can multiply A with C. And if you use, instead of the head, you check out the tail, then we can see that now we have a new column that we just created. If you want to delete a column from a data frame, you can either do the del, df, the name of your column, or you can use df that drop, and you can pass in the label of the column that you would like to drop, or in the column section. So you can put in the exact same name of the column that we just created, pass it in, and then you got to tell it the axis. So this is very important, a very important concept in not just Pandas and NumPy, but also in DAsk. So if we say axis 1, we're going to get rid of the column. And now we don't have it anymore. But because that wasn't an operation that was in place, we will have to either reassign it back into the data frame, or we should say in place equals true. Okay, so that's a quick and dirty introduction to Pandas. Everything that one of the last functionalities that I wanna mention about Pandas and about NumPy is that both of them work with broadcasting operations. What that means is that whatever I add to one value to one array, it will add it. If I try to add a number or multiply a scalar by an array, it will multiply that entire array. So what that means is that if I say array plus 10, now I'm going to have plus 10 added to all of those. If I change this for df at a, then we're going to have a 10 to the column A added to every single one of those values. So that's a very important concept, and we're going to take advantage of it throughout the tutorial. Now, with DAsk, so imagine that we wanted to save 5 data frames, and say we're going to say for data in, actually for I in range 10, df that to, and I'm going to create a new folder here, and I'm going to call it temp data. And what I'm going to do is I'm going to save 10 of these tiny data frames to explain how DAsk works. So I'm going to save in my new file. I'm going to use an F string. And what did I just call that one? temp data. In temp data, I am going to save 10 files. My file, and then I'm going to use the letter I to denote all of these files. CSV. And I'm going to save these 10 files. So if I go to temp data, now I have 10 files. They are all the same. Doesn't really matter. It's for example's sake. And what we're going to do is that we're going to import the main tool that we're going to use today, and that is DAsk array. So we're going to import DAsk not array, DAsk data frame.
Ramon, when you get a moment, could you just zoom in a couple clicks?
Yeah, of course. So awesome. we're gonna import DAsk data frame, and the alias that is often used when you import DAsk data frames is DD. So the way and then just like with Pandas, we use DF to represent a data frame. With Dask, we use DDF to represent a Dask data frame. So the way in which Dask works is that if you've heard the module, if you've heard or you heard of or used the module glob, it allows you to glob files from a directory that using string matching. So if I say read CSV, and then I go to temp data, what I can do is, if I know all I have there is CSV files, I can use a wildcard. Oops, that is not a wildcard. That is a wildcard. A wildcard, and say .csv, and everything that finishes with a .csv will be read by Dask. So long as they all have matching matching columns and everything. Oops, I did not save this one without the index. Index false. Let's save that again. Okay, now we don't have that messy index. So a couple of things that we should note or that are important to keep in mind. When you are working with Dask, you are building, you're usually working in a way in which you are building computations. You are doing an analysis, you are moving parts along the way, and you are lazily evaluating those parts or lazily evaluating those computations. So what does that mean? That means that, for example, right now, even though you see this representation of what a data frame is, Dask has not read any of the files yet. It has read just a little bit to figure out what is the data type that each column has, what are the names of the columns, and how many partitions should it have. So right now it says it has 10 partitions, and it read and it has 10 tasks. The tasks, each one of those tasks are, okay, go ahead, grab this file, and then read it into memory. If we start making some computations and adding new things to our data frame, then we want to start building on top of that. What does that mean? That means that if I want to create a computation, say I want to create a new column, I'm going to call it new column. And that new column, I want it to be the addition of column A and the addition of column C. I don't want to add that maybe immediately back into the data frame, but I want to start building computations. So say I'm going to do now, I want to add this column back into the data frame. So instead of running that and having that work in memory, what I will do is that I will create a second data frame. And I will say, okay, for my DDF1, I am going to assign my new column. And that new column is going to be called new column. And when you run that, nothing has happened yet. The computation, it hasn't been computed. So there's a couple of ways in which you can compute in Dask. And one is the head method and the tail method both trigger computations. So if you notice here, when you check out the doc string of the head method on a Dask data frame, it says that it will compute true. You can turn this off if you like, and then it will not do a computation, but usually that is turned on by default. So if I do a head, you can see that now we have a new column, but if I take the 1 out and I do head, it's like it never happened before. So that goes by going step by step doing an operation. So let's do one more to bring this concept home, and then let's showcase what will happen, or what does the graph of those computations look like? What does the graph of those computations look like? So I am going to copy this part over here and paste it down here. And I'm going to say my second column, and I am going to divide, no, not divide, multiply columns B and D, and subtract. And notice that I need to use DDF1 this time. Okay, so I'm going to run this one, and then I'm going to reassign it now to a new data frame. And I'm going to call it DDF2. And DDF to DDF1, I will assign that new second column. Okay, so now if we were to look at the tail of the data frame, we can see that we have the new second column. And lastly, if we want to see what computations have happened, we can use the method visualize. And it will print the sequence of operations that have progressed in our analysis, the things that we have done. So first we read in the data. And okay, sorry, it starts from the bottom. So first we read in the data, then we went into the get items, then add a column, then assign it back into the data frame. Then we did the exact same thing, but with 3 columns. We added a couple of columns together, multiply another one, brought it back in, assign it back into the data frame, and now we have a new partition into the data frame. So that is what has been happening with DAsk. The last thing I want to mention is that you can, just like you can interoperate, if you remember our Pandas data frame, just like you can interoperate with a Pandas data frame and with the Nunpai underlying data structure by calling values. You can also do the same with DAsk by calling values. And what it will show you is that it has 6 chunks, 10 chunks, which is equivalent to the CSV files that we just read. So in the same fashion, if you look at the type, then you can see that you have a DAsk array core. If I take the values out of it, then I have the DAsk data frame core. And that is sort of the key concepts behind both. Now, let's dive a little bit deeper into exploratory data analysis with both. So I added all of the files into a Google Drive folder. So it says that they all finished. If you had any issues whatsoever with Treasure It, which I am downloading my own file here and I'm going to cancel it. If you had any issues whatsoever with Treasure It, make sure you go to the Google Drive version of it. Okay. The link is in the, thank you, James, for sharing that again. So the link is, the link is there in the chat. And remember, if you are going to be working with, is there an advantage? Damien has a very good question. Is there an advantage of the assign format than to using the DDF column? And yes, there is. And the reason why we don't want to assign this back into another column is because we will have to put back we will have to assign it to the same data frame. And we will not essentially be building a computation on top of, like, So it depends on your use case, I guess. If you want to start building a computation where everything you are doing is lazily evaluated until you click compute, until you say compute on something, then um, then yes, then go ahead and build the computational graph however you like. If not, if your goal is to build a complex set of operations, or not necessarily a complex set of operations, but something where you are analyzing things step by step, then you want to assign them to a new object and build on top of the previous one. So somebody's getting an error when you're running the first cell on EDA. Is it in this cell, Julia? And what is the error that you're getting? Okay, so Marco, so this must be that you are in the binder session, is that right? Okay, so if you are in the binder session, what you will need is, try restarting now. What you will need in the binder session is to have the folder called data. So right now, what binder is doing is that it's going back one directory. So I am in the notebooks folder. So then it's going back one directory, and then, oops, I got a server error. So once it goes back that directory, it tries to find, let me use it with my desktop. So it tries to find a folder called data. And then in that folder, so if you see, it's trying to go back one directory, it's trying to go back to the data folder, and then it's trying to go to the final one. So that's what it's trying to do. So when you load the data into Binder, and I'm gonna have to restart this one. When you load the data into Binder, what you will want to do is to have it in a folder called called data. Or what you can do as well is whatever folder you go, you name it as, you change this one here or this one here to that folder. Yes. So you can check if the path exists with the code that Damien has just shared with us. So if you use, let me see if I imported OS. I have not imported OS, yes. So if you import OS and you do os.path exists data path, then it should provide you with a true if it does, and if it doesn't, then the data is not there. So what you need to make sure is that when you go into Binder, that you have it going and searching for the data in the exact same folder. In mine is one back, data, and then in a folder called final. Julia, let me know if you have issues getting access, getting the data once you get it into Binder. And Amanda said, this helped me. I had originally saved my data in the notebooks data, but moving it up one folder tier fixed it. Okay, awesome, fantastic. All right, so let's get started then. With the EDA, I'm gonna zoom out a little bit, but let me know if it becomes, oops, that was zooming in. Let me know if it becomes a little bit difficult to see, and then I will zoom back in, okay? So, all right, so let's talk about this one. So my hope is by the end of this notebook, you will have a better understanding of exploratory data analysis, what it is, how to use it, how to do so with DAsk, and many data frames. Let me explain a little bit of the data before we dive much deeper into it. So there's this fantastic website or tool called Inside Airbnb. What they do is that they periodically scrape data from Airbnb, and then they post it and they have it freely available online. The data is usually quite messy. So to get this data set clean, it can be quite a challenge to have all of them. Some countries, they don't have the exact same, they don't track the exact same variables, or maybe this is due to regulations in that country and Airbnb not being able to post or to ask for the same information or post the same information out there if you want to go and visit that country. But for the most part, they do have many similar variables. So if you scroll down in the section, it tells you everything about how inside Airbnb does this. And then in the get data section, and I can see that this is a little bit small, so let me zoom in a little bit. You have data for every single city where Airbnb has operations at, or sorry, not every single one of them, but for a lot of them. And a lot of the cool things that you have is that you have the listings, you have reviews, you have the neighborhoods GeoJSON files as well. And that is very, very useful. So what we have here is a condensed version of a lot of the data inside Airbnb. And in particular, we are working with 41 markets today. And let me explain, or let me show you what that looks like. So, all right. So let's get the data here. So if you notice, you're gonna notice something very unique to this tutorial, or the way in which I have set up the data. And what I did is that I split, when I did the cleaning of all of this data, which was about 130 gigs, I cleaned them all in my computer, 8 cores and 8 cores and 8 gigs of memory RAM. So I cleaned those in a couple of days. And what I did was, to make it easier, and for the purpose of this tutorial, is sort of imagine that we're planning a vacation and we're interested in knowing and finding out, okay, where should we go after COVID? What is the best place for us to go to? Well, we want to know, first of all, we want to stay at a place. We probably want to stay at a place that is affordable to our means, that we can afford. We also want to stay at a nice place, and we also want to figure out other things about the tutorial. So what I was one of the things that makes it a little bit messy, or a little bit convoluted or complex to work with such an amount of data that might be in different formats, is that if you have different cities or different markets or different countries across the globe, not the prices that you will see in one doesn't necessarily reflects the price that you will see in another. So in order to do a large scale analysis with a lot of data, and then do so in a way in which you can parallelize your functions and your questions to each one of those cities that you're interested in order to do that, to make that feasible, one of the ways that I thought of was, okay, well, make the index of every single partition of your mini data frames, make it that market that you're interested in. So you're going to see here n partitions for 41 partitions and for 40 markets across the globe. So London, New York, Los Angeles, Toronto, Vienna, and whatnot. So all of these partitions represent a particular market, and we have a total of 41. And as you can see up here, you're gonna have 41 because there's 41 markets. So okay, so I'll keep explaining a little bit more about the data as we go. A couple of useful functions is that we have about 28, 47, 67, about 70 or so variables in this data set. And with the dat info, if you used Pandas before, you will notice that the dat info will tell you how many variables are missing and so forth. But Dask info will not go and check the data itself, because it might be dealing with quite a lot. What it will do instead is that it will tell you the data types. It will aggregate the data types of the columns that it has detected in your data frame. Now, if you are interested in learning a little bit about how I clean this data, I did this in SciPy last year, and you can find it in my repo. I showcase how to do the cleaning of this data set in my SciPy of last year, and you can find it in, where is it at? In SciPy Japan. And there we did the data cleaning at scale thing. So this one has already been cleaned. And now a couple of things that you should keep in mind. The first one is that head triggers computation. If we have a lot of data, this can be an expensive operation. Because the data is coming from Parquet. Parquet is a columnar columnar data format, which makes it works very seamlessly with DAsk. So what the head would do is that it would actually not take that long to compute it. But if you have messy CSV files that have not been properly parsed yet, then you might run into some issues when you try to run the head method. So as you can see, we have a lot of information that gets captured. When you think of Airbnb, there is a ton of information that gets captured from hosts and in a listing. In a listing website, you see the price, you see the amenities that you will have, you see a lot of things that you might that interest you when you are about to rent a place for a week or a weekend or so. So as you can see here, we have a ton of stuff, and part of the cleaning process, you might see these were unknown whenever there was a missing file for a textual variable, then I replaced it with unknown. Some of the other variables have been cleaned in a way in which they have the median has been imputed. Others have been cleaned in a different process. For example, if there's a missing review, but the person has never, the listing has never received a review, well, that should be assigned to a 0. Otherwise, then there were other tricks that I used to clean this. But for the most part, here's all the information that we're going to be dealing with. And this is Amsterdam, and that is the very first partition. So that is taking the first 5 rows of the first partition. Okay.
And then there's been a couple of comments about just the speed that you're going at. If you wouldn't mind just going a tiny bit slower, I think that might benefit some folks.
Oh, yeah. So, sorry. Please let me know if I do start accelerating.
Yeah, for sure.
I do tend to go quite fast. Thank you.
Yep, no worries.
Okay. Awesome. So the next thing, if you want to see the last 5 rows, you can also check them out, and you will see that here we have Vienna as opposed to Amsterdam. All right. So for those of you who would prefer to work with a smaller fraction of the dataset, so that way I know that broadcasting and having a video on a live session, it can drain a lot of resources on your computer. So I highly suggest that you take a fraction of the data set. And then this is a new method that I'm going to introduce now, and it's called persist. When you have done, as I mentioned previously, you usually want to start building computations as your analysis gets more and more complex. When you are in a distributed system and you do a very expensive computation, you usually want to persist some of those changes so that you don't have to go from the very beginning. Imagine having 10 steps or 15 steps, where the very first one is reading the data, and then the very last one is compute some sort of algorithm. Then you probably don't want to start all the way from the very beginning at every single time you evaluate your computational graph. So one of the things that you might want to do is to persist the data frame at a given point in time in your calculations. So what we will do here, so that way you don't have to read in the data every single time and then come back and take a fraction of it, a random fraction of it, what you can do right now is to take 30% of the data set. So right now we have 1.8 gigs of data. And as I mentioned earlier, it's about uncompressed, it's about close to 6 gigs of data. Okay, so here it says DDF runtime error compressed snappy, but not available options, broadly uncompressed. Okay, do folks typically partition their data on meaningful variables like geographic markets so that you can do a separate analysis for each market, or do you partition your data based on other considerations? So Rebecca, that is a great question. So what I did in this one was that I was thinking, say I want to go on a vacation, and I want to do some analysis on each one of the markets. Instead of having markets aggregated differently across partitions, it will be more efficient to do an analysis in parallel if I have them separated by each partition. Of course, this is not perfect. This is probably just my use case, but one typical use case that I see that I've seen a lot in tutorials with Dask and blog posts is the one where you have dates as your index. That makes it very easy or much easier to deal with partitions and get one versus the other than if you have them all scattered around in different blocks of partitions. So once you, could you make sure you have snapping style with conda? Oh, thank you, James. So yeah, so it's uh, the files are compressed in with snappy format. So it is possible that you will need an additional thing, an additional dependency to be able to read them back in with Parquet. And one thing I'll do here, in case this comes up again, because it very well could, what I'll do is that I will create a Excel version of the, not Excel version, a CSV version of this, and I'll also push it up so that when we take our first break in about 10 minutes, then when everybody comes back, then you will also have access to a CSV version of the files. You get the names of the cities correct, but it is empty. And Carmen, what do you mean by it is empty? When you run the df tail, you don't see the data frame? And I wonder, CSV final 21. Okay, so it could be, Carmen, are you in Binder? Okay, I guess that's the first question. Or are you in your personal computer? You're in Binder. Okay. Is your file, is your path to the files the correct one? Are you going back and searching and going into the folder where your data is at? So if I come here to Binder and I go into the notebooks, oops, my Binder timed out. But so so I'm gonna launch my Binder, I guess. So Carmen, the main thing is that you have to, when you get the data up in Binder, make sure you have it in a location where it matches the join here. So for example, if you have it in your, if you go to your notebooks and you have it in your notebooks, you put the final folder in your notebooks, erase all of this. Erase all of this and just have, or just leave final if that is, if it is within your notebooks folder. So just leave the oops, sorry. Just leave the final one if it's there. So it might be that it's not found in the folder. The other thing is that you can check if so, you can also move it into a folder called data inside the main area of Binder, inside the main repo, the Binder opens. For those of you working in Binder, I highly recommend that you do the fraction because Binder has limited resources for you to work. Adding Snappy to the environment did not solve the DDF error with DDF head. Okay, so what I'll do, okay, I created this one, it already exists. What I'll do is that, let's do this. Let's take the first 10-minute break now. I'm gonna save a CSV version of it, and I'm gonna put it in the Google Drive folder. That way, everybody can have a smaller version, so that way it doesn't take you too long to download, and you can use that one for the tutorial. So let's take a 10-minute break. Come back in. So it should be 2:55 in Central Daytime. So let's be back here at 3:05, and then I'll have the data folder there with a non-compressed CSV version of the data. Okay, so I should be able to upload those here in just a little bit as soon as this finishes. So I think the 30%, Marco, is if it runs out of memory, then yes, decrease it to maybe about 1%, or even, yeah, 1%, I would say should be okay for Binder, because it will come to about much less than a gigabyte. So I think 1 will be fine. If not, then try to play with that fraction number. Oh, you mean like take a zip file as opposed to? So when you say zip it, you mean like okay. Put in a zip with all the CSVs, and okay, perfect. So I'll do that. Let me put it in a zip file. Okay, Carmen, where is the file at right now? Where is the folder at in the Binder session? So right now, let me go to Binder. So I'm on Binder right now, and I'm in the notebooks. Did you upload it here in the notebooks? Okay, is that where your final folder is at? So the folder name final, did you upload it here in the notebooks folder? Do you see where I'm at the top? Or do you upload it up here? Okay, so if you put it here in the notebooks, and then I open the notebooks, I open the first one, EDA. What I want to make sure I do is, and when I come down here to the data path, what I want to make sure I do is that I delete this and this, because if we had a cell before this one and we add a PWD to print the working directory, it's going to say that I am in the notebooks folder. So because I'm in the notebooks folder, my final file is already there. So you want to use this two over here. You want to pass in the file to this one. Okay, so that did not work. Okay, so I'm going to try and do it myself as well. You think that my files are wrong? No, I don't think the files are wrong. Let's see. I am about to upload the CSV files. Okay, so here is the zip file. Oh, that is a file. Okay, so hopefully that doesn't actually take, okay, 5 minutes. Okay, awesome, Matthew. That sounds great. We have about 2 more minutes of the break, and then yeah, we'll go through that. Sounds great. We'll troubleshoot during the break. No problem, Carmen. So, Magdalena, what I did was that I'm adding a CSV version of the dataset. So maybe it will be much easier to use this one. Then what you will want to do once that is ready is instead of using, and I put this line of code in the chat as well. Instead of using dd read parquet, what you will want to use is ddf dd, and let me make this a little bit bigger. Read CSV, then the data path to that, and then you want to use one last thing. You want to use the block size equals none, because when DAsk reads CSV files, it usually reads them. What was it again? It usually reads them and it creates its own partitions. The default is 64 megabytes. So we want to keep the order of the partitions because each one of those contains a market, and that's very important for the rest of the tutorial. So we want to use block size none when we're reading those CSV files, okay? That will be the only difference once you download that folder that is about to finish here. So the CSV files, I completely misspelled that, but oh well. Let me put the line of code here. That is the read CSV path. All right, so 6:05 for me, 3:05 for all of you. Let's go ahead and continue. That should be almost done. Once it's done, remember, use those CSV files. That should work exactly the same as with the Parquet ones, okay? All right, so let's continue. So what is exploratory data analysis? So exploratory data analysis is an approach. It's an approach to exploring, learning more about your data. It is a process by which, in which we can actually get to test hypotheses, get to test some models, But usually the focus of it is in describing the data in different and meaningful ways to help us to answer questions such as what is the average price of X? What is how many categories of Y do we have? And so forth. Your code fails in line 2. So could it be in this one? So what I'll do is once this finishes uploading, or actually even before it finishes uploading, so I can go ahead. So right now I am in my Jupyter, I am in Binder. And if you go to the top to the upload button and you have downloaded the files, the CSV files, the decompressed ones, once you decompress it, make sure you upload them in, and I wanted to upload the whole thing. Let's see. So if I go, okay, I'm gonna create a new folder here, and I'm gonna call that folder, well, I guess I'm gonna call it, Untitled. Okay, so I'm gonna go to that Untitled folder, and there I'm going to click upload, and then in that upload, I'm going to select all of those CSV files. Yes. And I guess it's going to ask me for all 50 files if I really want to upload them. So yes, I do. I guess that is what all of you were referring to, that it was a zip file and it asks you to like do each one of those. So I can't recall this happening, but what you want to do is you want to have them all in one folder. There you go. So once you have them all in that folder, you go back to your notebooks. And right now mine is frozen. So we will have to come back to this. But once you have them there, whatever the name of that folder is, that is the name of the folder that you're going to use in here. So you're going to change final. You're going to change it for that number, for the name of that folder. In mine, it was what? Unknown folder. So that is what you're going to have there. Then you're not going to use the read parquet one. You're going to use DDF that read CSV, and you're going to have your data path. And something that I forgot earlier was, oops, with the CSV files, you actually have to have a escape character, or not escape character, a wildcard. And you have to have that CSV, and then that will select all of the CSV files in the unknown folder where I just uploaded all of my files. Okay? So you will use this one, and then you will use block size equals none. Okay? And that's what you should, that would allow you to read in the data. But remember, the key thing is that it has to be in the same file where you are uploading it, okay? All right, so I'll go ahead and continue. And let me know once you have the data inside Binder if you have any issues getting it there. Untitled folder, yes, that one. Okay, awesome, Sumida. I'm glad that it's working now. The last line, yes, of course. So actually, you can take this even out of here, and you can put it here. It was Untitled folder, on, don't restart, Untitled folder. So, Manuel, that is a great question. Is it a good practice to use block size none? Not necessarily. If you're dealing with CSV files that have already been partitioned in the way you want to partition, then yes, use the block size none, so that way you work with the partitions that you want. In this instance, it's very important for the tutorial that we use those blocks as they are, because they are partitioned by market. And if we were to not read them as such, DAsk will create partitions on its own. And I believe the default is 64 megabytes per partition. So it is important that we use that block size none, because it tells them don't partition it. Like, just use every single one of the files as they are and read them in as a partition. All right, so let's continue on. We are a little bit, okay, cool. So we were right here. So exploratory data analysis, it allows us to spot further inconsistencies in the data. It allows us to answer many questions that we might not at the time that we're modeling. Usually when we get to the modeling part, we had a previous question. We have something we set out to solve, or something we wanted to take account or to disprove, a hypothesis, a problem that we needed to solve. And then we get the data to try to solve it. And then once we get the data, we might want to analyze it in many meaningful ways. But once we get to the modeling part, we're very interested in going back and answering that particular question that we initiated a project with. So in exploratory data analysis, we take a step back and we do three things. And if you take anything from this section, I want you to take these three things. Exploratory data analysis can be split very often into three categories: confirmatory, exploratory, and explanatory. And those are three ways in which you can think of it, or a framework that you can use to think about exploratory data analysis. Am I explaining something to someone? Am I confirming something for my team? And am I looking to explain something? All right, so some of the questions that we are going to explore: how many observations do we have across all markets? How many regular and super hosts does each market have? Later on, we're going to test the hypothesis whether regular hosts and super hosts charge the exact same price for a listing per night in Airbnb. So we're going to do a few different kinds of analysis throughout this one and the next notebook. So, all right, let's get going. Here are the questions. I repeat them at every step of the process, okay? All right, so let's talk about the key component or key ingredient of exploratory data analysis, and that is descriptive statistics. So what is descriptive statistics? Descriptive statistics is facts about the data. We have data. That data was supposedly generated by some processes, or by some kind of process. Usually, we like to believe, for a lot of statistical analysis, they assume that data has been generated through a random process. In some of the instances, data might be generated through a specific process, through a pseudo-random process. But more often than not, we assume that this data was generated through a random process, and a statistic is a fact about it. A fact about it might be the raw count. How many observations do we have for that particular data set or particular observation? What is the average of that? What is the standard deviation of such, and so forth? So those are some of the things that we want to do with descriptive statistics. So let's get started. So in DAsk, you have the data set will behave in many different ways. And there are a few, I mentioned earlier that there are a few functions and calls in Python that will trigger a computation with DAsk. Some others won't. And here are some ways in which you can get the length of a data frame. In particular, the len is one of those other ones that will trigger a computation. So if your data frame is very, very long and it has a lot of, it has lengthy partitions, or maybe it doesn't have lengthy partitions, but it has a lot of partitions, then the len might actually take quite a while to compute. The df shape, if you do not call compute at the back, then you will not get the length of the rows that you have in your data frame. Map partition is, earlier you saw how we were working with a Pandas data frame, and then we went to work with a DAsk data frame. If you want to compute something in those partitions are Pandas data frames. And what that means is that we can send computations to each one of those. And one of the most useful functions in DAS data frames to do that is map partitions. So, and confirmatory, exploratory, and explanatory. So sometimes you're not trying to confirm something necessarily, but you want to explain something. And maybe that explanation is not, you don't have it grounded in some statistical test, but it's more of a fact that you observe in the data. And I took those three from an excellent tutorial by Enrico Bertini from New York University. He's an excellent data visualization researcher. All right, so the last one or the last two is if you want to check, in our case, we are dealing with partitions that have a specific index. A specific index meaning that they have, the partitions are representing something that we're interested in. So we can use the value counts to get that back and get the row count of every single partition by the market. And we're going to check what that looks like here in just a second. We can also do the count and add compute to it. But if we don't use a particular column when we check for the count, the DAS data frame will bring down every single one of the columns, the count of non-zero or non-missing values in each one of those. So make sure you keep those distinctions in mind, and they are up here for you to come back and refresh your memory on those, because that's very important. All right, another thing that we're using here, when we're doing a computation on a large data frame, so Binder crashes when tries to upload all of the CSV files. I wonder, having no luck with this one either. So I'm gonna try to do, what I'll do is for the next break, I'm gonna try to do even smaller versions of the data frames, and then I'll try to put them in a compressed CSV format, so that way you can still read the compressed CSV files, but it will be much smaller. So instead of having 30 megabytes per partition, you will have about 10 megabytes per partition. So I'll try another one. I'm sorry about that. Now I made it into the progress bar. Okay, awesome, fantastic. Okay, so the progress bar, what it does is that it gives us sort of a time frame of what is happening and how long the computation is taking. So let's click on the M's notebook Python 3.7. D-type warning column 23 have mixed types. Specify the D-type option. Okay, that's right. Yes. So you have to have the wildcard so that you can read all of the ones that, all of the data sets. So if I go up here, say for example, you have it in something called data path. So you have to have the wildcard, that's CSV, so that it reads all of them, because he might just be trying to read one one CSV file right now. Thank you, Damien. Okay, so here, when we use the progress bar, what it does is that it gives us a little line telling us how long the computation is going to take. So notice that right now we're dealing with 460,000 rows. Remember, I took a fraction so that my computer doesn't slow down a lot, but I took 30%, which means that there's about 1.5 million rows across 41 partitions and 71 columns. So, or about 70 columns. So that can take quite a bit of time to process if the lengthier the partitions are and the more partitions you have. Okay, so something else that we're interested in. So another question. So the first question is, how many observations do we have across all markets? So across all markets, we have 460,076. So how many superhosts and how many regular hosts do we have? So we have 37,000 regular hosts. So the F for this particular categorical variable means means false, means that is a regular host, and then true, host is superhost, means that is a superhost. So we have about 81,000 of one, and then 378,000 of another. Another question, so how many observations do we have per country? Now, I want you to notice here that for the len, we are not using that compute method. But if we call the value count without the that compute method, what it does is that doesn't evaluate that computation. And it says, I have 130 tasks to run. So I have to read in the data, get a fraction, but at this particular moment, we don't have to get a fraction because again, because we persisted part of that operation. So what it does now, it says, well, I gotta go and get the superhost, and I gotta split the data, and then I also have to split the data, but then I also have to get the count of each one of the markets for each partition. So it says I have 130 tasks, and unless we call compute at the end, task will not give you a result back for that. So make sure you keep that distinction in mind because that's going to become very important as we move along. Okay, so the next question is, so how many observations do we have per country? Which is something that we want to know. How many per country is not the same as per market. In per market, we have New York, we have LA, we have Seattle, we have quite a few other cities that might be in the exact same country, but we don't have. So countries do not equal markets. So we have 41 markets, but not 41 countries. So let's see what the value count of this is with a visualization. Now we are using a particular plotting library here called hbplot. hbplot allows you to work with Pandas data frames and DAS data frames, both alike. The only requirement is that you have to import at the very beginning of your session, you have to import hbplot.dask and hbplot.pandas so that it would allow you to play with the backend of those two. If you don't, Pandas will default to using matplotlib, and which is great. But then the nice functionality of hbplot is that it allows us to use bokeh, and bokeh is an interactive plotting library that makes very beautiful plots. So here, another thing that I should have mentioned earlier is that we are using HoloView. We are also going to be using HoloViews, which is a great tool for data visualization. It is built on top of matplotlib and bokeh. And one of the requirements is that you need to tell it, or you should tell it, what backend do you want to use when you're making visualizations. So right now, as we said, bokeh, and that is why when we build hbplot is built on top of HoloViews. So that is why right now we get to see a nice bokeh visualization when we call hbplot.bar. So here we're using the rotation method so that all of them are not lined up on top of one another. And then we also have a nice hover, and it tells us, so Canada has 32,000, we have 32,000 observations for Canada, or about that. Australia has 46,000, where I'm at. The UK, 50,000, and then the US, of course, has the majority of them. But we also have multiple markets. We have Seattle, we have Portland, we have Los Angeles, we have New York, and I believe we have Chicago and Washington, D.C. as well. So quite a bit in comparison to the other countries. In Australia, we have Melbourne and Sydney. Okay, so the next thing is that if you have questions about how hbplot works, you can use the two question marks at the end of the plot of the function, and you can use enable scrolling if you don't want to scroll endlessly all the way down, and then you can see all of the options that hbplot.bar allows you to use to manipulate the way in which your figure will look like. Then you can also use help around that same operation. It will give you the exact same thing, but in a slightly different format. So we say like X, none, and whatever. Well, that also appears in the other one, but it will give you all of the options. And then below that, you have what each one of these options does. Okay. All right. So time for a quick exercise. So how many observations do we have per market? Remember, above we did it. we did it per country. So now we need to know how many observations do we have per market. Then how many markets do we have per country? So you can remember, you can look at your data frame with a head, and you don't need to look at all of the rows. You can say, show me only 2 rows. And then here, you also have the market as the index, but you also have the market in a column of its own called market city. So if you remember from above, we took the country and we took the value counts. This can also be used in the same way in which we aggregate, in which we select keys from a dictionary. We can take that dot out of it. And now we have the exact same representation. So I'll give you 2 minutes to finish the first one, 2 minutes for the last one, and see what you come up with. Why is it saying the count is country? So the count is country. Oh, Tom, great question. So when you use value counts, this returns a Panda series. The index of that Panda series is the name or the category that you're grouping by. The values of that Panda series is the numerical values. So the name of the column is country, and then the numerical values are going to be what's in the line, what's in the Panda series, and then the index is going to be the country. So actually, let me show you what that looks like. You have to call compute on it. And what compute does is that it brings back a Panda series. So as you can see, since this is a series, you got the name, country, and then you got the index as the countries that we have, and then you have the values right next to them. Okay, so for the first one, so the question says, how many observations do we have per market? Well, we can use the exact same. I got stored in the first progress bar, try to run it out and got this error, corrupt, snappy, compressed data, but no issues reading in the data via Parquet in the earlier cells. So you were able to read it in, but then you got an IO error when you try to take a fraction. Is that right, Ramona? Okay, so maybe the CSV files will work better. And as I mentioned, I'm going to post those in the next break. You could also try, there is I think James put earlier the line of code to download Snappy, or that part of it. So if you scroll up in the chat, I'm sure it is somewhere there to download Snappy, and try downloading that during your notebook, and then restarting the notebook and then running it again and see if the Snappy works. Oh, there it is. Thank you, James. Okay, so for the first one, we want to know how many observations do we have per market. So we can select the index because that is what we're using here, or we can also call it by market. We're going to do it by index. We're going to use the value counts method. Remember that when we use the value counts, it is a lazy computation. So we need to tell DAsk that we want to compute it to give us the output of it. And now we have all of the observations that we have per market. If you want to visualize it, as you saw it above, you can use HB plot that bar again. If you don't add any parameters whatsoever, then you will have if you don't have at least the rotation parameter, then you will have the labels in the x-axis all on top of each other. So make sure you always do, if that is the case, that you add a little rotation bar, and then that way you can see them all to the side. So then the next question was, how many markets do we have per country. So one thing you can do, remember that you have a second major city option or column. So one thing you could do is df that, if you've ever seen this operation, the group by says, for each of these categories, I want to do something. I want to calculate a particular statistic. So if we group by country, and we take the major city, and we do unique, we could call compute on this. And see how many do we have per, oh, sorry. So we need to use n unique, which means instead of telling me one city that we have, tell me the name of the city that we have, tell me the number of the cities that we have. So n unique, let's see if it shows it. Okay, good show. So n unique will tell us in the United States, we have 10 cities. We have 2 for Spain, which I believe is Barcelona and Madrid. In Italy, we have Milan and I believe Rome. Australia, we actually have 3. Oh, yes, we have Perth as well. Canada, we have 2. And then everywhere else, like, or most of the other places, we have 1. Okay, so those are the 2 ways to get those 2 questions. Let's go to the next one. The mean, also called the arithmetic mean, can be calculated in many different ways, and this is a very important statistic that we always want to showcase, either to people or whatever. Whenever you see the news, oh, the average rate of COVID or the average amount of COVID cases per day has reduced by this much or increased by this much, you're getting a statistic, an aggregate version of an array of data or an array of information. In DAsk, we do this in sort of the same fashion as the very last option in the last section, in the count. Instead of that count, we use that mean, and we have to select the particular column that we're interested in. Otherwise, DAsk will go search for all the numerical columns, just like Pandas would, and give you the mean value for all of those numerical columns. So you can also group by a categorical variable and then get the mean of that numerical column. You can map the NP mean to a particular column in your DAsk data frame as well. And then you can also use anonymous functions to get a particular value from your data frame. If we use hpplot, we don't need to compute, right? Oh, that's a great question. I don't know. Let's try it out very quickly. If we do or not. Oh yeah, we don't. Great observation. I did not know that. So awesome. Thank you, Amir. Fantastic. All right. So what is the average? So let's go right into it. What is the average cleaning fee per market? So earlier, we used a group by operation. Now, here's a little trick. When you want to increase the efficiency of your computations, especially if you're working in parallel, if you're working with very large data sets and you don't want to wait forever. So try to select, before you do the group by, try to select the columns that you are going to group by, or try to select the columns that you're going to be using in your group by operation. Here, we're going to use the major city, which is also the market, and then we're going to use the cleaning fee. We're going to group by that, by the market, and then we're going to use the cleaning fee. So technically, we could get rid of this one over here because we're grouping by the market, or we could group by that major city as well, because both of those are the exact same column. I can't remember why I left that second one there. There was a reason in my head at the time when I was cleaning the data, but oh well, we got 2. So then we take the mean, we call compute, and then we have the clean groups mean. So notice that operation took 2 seconds. I am currently using 1/3 of the size of the data, so about 1.2 gigs or something like that. Remember that the full size of the data set compressed is about 1.8, 1.9. Uncompressed is between 5 and 6. So I have 1/3 of that right now in my computer. Okay, so now we have the average cleaning fee for all of these markets. One more thing that is very important that I mentioned, all of these files, all of these prices have been converted to US dollars. Originally, they were not. I used a package in Python called import currency converter. That is the package that I use to convert all of that during the cleaning process. So just so you know, if you wonder, like, hey, is this in euros? Is this in euros and whatnot? Is this in Argentinian pesos? No, it is all reflected as US dollars. Okay, we can also visualize the group once we have brought it down to a Pandas series. And notice that you can add a that sort value at the end of your call for HP plot, and then sort your plot however you like, in descending or ascending order. Okay, so the last version that I wanted to show you, which is very, very useful, is if you have a unique value that you're interested in and that it represents the partition of your data frame, then you can certainly select that with a unique method. So here we're saying, Lambda, take that data frame that is the partition of this dash data frame, take the index of that data frame and return a unique value for it. We're going to select the first one, if there are many. Then take the mean of whatever column I'm selecting. So notice that here, I am selecting a particular column. But so now I'm getting the average, the same value that we have above, but now we're getting it with the market right next to it. So notice, if I take this out of here, because I am saying Lambda, take X, X will represent the Pandas data frame. We could do here, we could leave the X selecting the index, but here, what we could do is add the column, and we will get the exact same results. So it's mapping one to the other. Map partitions is always operating in tiny Pandas data frames. Okay, so the next question. How have the average price and cleaning fee of hosts changed since joining Airbnb over the years in X market, where X market can be any market of your choice? So that is, notice that this is a tricky question because in our data frame, what we have is DDF hit. I used to. What we have here is we have a proxy for when a host joined, but we don't have a proxy for across the years. So what we have is sort of like, how has the price changed when a new participant in the market comes in? So you could reframe that into sort of economic terms. When new participants come in, do they drive the price up? Do they drive the price down? And to do that, what we will have to do is we need to convert that host since variable here that has a date into a date format. And to do that, we can use the DAsk data frame function called toDateTime, which is synonymous with the Pandas one as well. And if you use Shift Tab, you can see the options that you have available in that call. So then we're going to convert this into a data. Once you do so, you have an attribute called DT for data. And then to that attribute, you can select a sub attribute called the year. You can also select the day, you can select the month, and you can select the day of the week. You can get very finely detailed with the datetime attribute. Then what we're going to do is remember that we are building computations. When we do operations on the data frame, we want to save them into a new version of that data frame. So here we have TDF1. Okay, so now we just added it back. If you are ever curious as to what is happening with your data frame, make sure you do visualize the same function that we used earlier in the Flash introduction at the beginning of the session. And then you can see what is happening with your data frames. Of course, the view is going to be a little bit tiny, and depending on how many things we have done, it can get increasingly more difficult to visualize what we're seeing. But this is a good representation of what has happened to each one of the partitions. Also, you can pass in a file name, my image, I believe PNG files, and then it will save the visualization of your computations. And you can see that in, say, for example, I go here to the notebooks, and then I have my dask.png. That is the default name that it uses. So if you run that visualize without anything later on, then it will overwrite the previous one that it created. So keep that in mind if you get curious. Okay, so here, what we're going to do is so what we were interested in, sorry, I went, I lost track of that. So what we were interested in is how has the price changed with hosts joining Airbnb over the years. And to do this, we're going to use an interesting plot called a step plot. And first off, we're going to group the data by the year the host joined. And then we're going to have that in our index column. In our group by, we're grouping by the years. We're moving that to the index of a group by object or a group by data frame. We're selecting two variables, the price and the cleaning fee, and we're taking the average of those across the years. So now we're going to plot it, and then we get this nice looking graph that says, so from 2008 to like the middle of 2008 or the first quarter, I think it's like the first half of 2008, then you had prices on average of about $137 per night. Then in 2010, that went to about 147, and the cleaning fee went up to 90. So one thing that you could do is if you're interested in a particular set of averages across the years, you could do a t-test to test whether the average of one year is significantly different than the average of another. And that could be a good hypothesis test. So that is called a step chart. And now for you, for an exercise is you have to create a step chart to evaluate the movement of listings over the years. So how does this, let me give you a hint on this one. So if we look at our data frame, and actually, let me just look at two. So the listings have an ID. And above here, we group by a particular market. So actually, and sorry, I forgot to mention. So this one is not all of Airbnb. This is in LA. So we could change up here to New York. And now notice how the graph has completely changed. And it is not the same as in LA. So you can change the market up here. I put it up there because it's a little bit easier than to change right over here. So think about this operation that we're doing here. So we want to know in our question, we want to create a step chart to evaluate the movement of listings over the years. So we have our data frame, and we have the new year's variable that we created. We want to calculate, or we want to see the movement of hosts, or not necessarily of listings. Every listing matches an ID. So we could take the ID, and we could take the count. We could compute that, and we could use our HP plot operation. Okay, I need to select this in a much more efficient way. So I'm gonna add a parenthesis so that I can go down to the next line and then continue chaining an operation. So what the parenthesis does is that it allows me to have all of that encapsulated in one nice little cell. How does making a new DAsk data frame for every change to the DF impacts the memory usage? So that's a great question, Kyle. So it doesn't impact the memory usage until you, or let me rephrase that. It can have an impact on the memory usage depending on how complex the extent of your computations are. If you have 16, if you get to that's data frame 16, and you have a lot of computations, you have not persisted each one of those. Remember that DAS is starting from reading in the data, doing the first one, doing the second one, doing the third one, doing the fourth one. So I guess the memory usage might continue to be the same, or it will lengthen the amount of time that it would take for that to compute all of those processes. So if you have a lot of steps along the way, you might want to persist it like step 8 if you have 16, or step 7, or so forth. Or and I think this is in the best practices part of that. If you do a shuffling of the data set, that is a very expensive computation, especially in a distributed setting. So if you do a re-indexing, or if you do a sorting of a data frame, make sure you persist after that one, because that will be a very expensive one, and that will keep you waiting for longer and longer the more new data frames you create after completing some computations. So it's important to keep that one in mind. So that's a great question. Okay, so here we have the ID. Let's see. Okay, I have an invalid syntax because I need to put the dot here. And here's our step chart for how and this is not in New York, by the way, this is in the entire data set. Average count of new listings. Okay, there you go. So this is how they have changed over the years. And I don't know if I am surprised or not that they have gone down the amount of people joining or listing their homes as Airbnb places after 2020 or during 2020. That seems to match intuition. So, okay, so let's continue. So the median, this one is very important because that doesn't allow you to use the dot median method that you will see in Pandas. And that is a very important computation, especially for imputing. Imputation is we have missing values on a numerical variable, and we want to compute the median value of the non-missing values of that variable, and then use them to fill in the ones that are missing. The reason why this can be a very difficult computation is because DAsk has to go through the entire data frame to get the median value of all of them. And I recently discovered that when you get the quantile of a particular column, you get the quantile, or you get the median of those partitions. So that's a very important distinction to keep in mind. The way in which you can get the actual median of all of the values is by first converting that column. So here I have the price column, say, and I am converting it to a DAsk array. I'm using length true so that it matches the chunks, and then you have to use an axis. So once you use that, once you go down to the level of Nunpai, then you can use DAsk array, so which has been imported as DA. You can use the median from it. Another option is to bring down with the compute, bring down that array to a Pandas array, or to a Pandas series, or to a Numpy array, and then compute the regular mean of Pandas or the regular mean of Numpy on those. So that's another option for that. So Leah said plot code without the fancy color adjustment is helpful. Oh, awesome. Thank you for sharing it. Okay, so here are, so what is the median price per market across the world? So let's see that. So here we are we're selecting the data frame, we're using the price, and we're taking the quantile. So the quantile will give us the median. And here it is. It's $151 with 79 cents across the world. All right. So now say we want to do the exact same thing, but instead of across the markets, we want it per market. So remember from earlier, we create a lambda x. We could also call this x data if it makes it more intuitive to follow what it's doing. So we're taking, so data here represents a Pandas series of the price column in each one of the partitions. So we're saying, take that series, grab its index and give me the unique value for that index, and take that series and get the mean or the median of it and give it back to me. So in this case, it is much more beneficial for us to get the median per market, because if we add other values across the world, then that might not help us to get to where we want to go. So the median of DC should not be influenced by the median of Florence, Italy, because they are two different places. So that's sort of a way in which you can see it. You would also have a use case for the median of the entire thing if you need to. So here is another way to get the median of the entire column, the entire price column, and it's by when you call compute on a DAS series, you bring it down to a Pandas series. When you go compute on a DAsk array, you bring it down to a Nunpai array. So notice here that we got the median of the entire data set, but the median of the entire data set is actually the median of the partitions. Now, the median of the entire data set is actually $85. So notice that if you see 151.79, that matches here the median of Amsterdam, which if we sort them all out, then we might actually end up with Amsterdam right in the middle of that. So keep that in mind, because the median is super important, especially for things such as imputation, sorry. Now, the last method that I mentioned was you have the two array and the length are equal to true. So we are essentially saying, we're essentially saying convert this into a NumPy array. I did a weird movement there. Okay, convert that into a DAsk array, and then from that, take the median using DAsk. So notice that we end up at the median of the true median of the entire data frame, DAS data frame, as opposed to the median of the partitions. So keep those two in mind. All right, so what is the median review score per market? Visualize it with HBplot. So DDF, that head, check out the review score. So if you scroll all the way to the very end, you have review scores rating at the very end. So what is the median value of this column? Review scores rating. And then can you visualize it with HBplot? I'll give you 3 minutes for that one. And then we'll go on a break in about 10 minutes. We're going on another break. So I'm going to do like a break per hour. All right, so I'm gonna go and skip ahead to the next section to try to, we're almost done with this one. I wanna make sure we complete it. I think we can complete it in the next 30 minutes, sorry, 10 minutes before we go on a break. So I'm gonna try to catch up so that we can get through the next two notebooks. Because in the next one, in particular, we're building a dashboard. And I think you're going to find a very, very useful skill, very useful thing to learn about. And we're also building choropleth maps, which are very cool. All right, so let's get to it. So the mode. The mode is the most frequent value that appears in a series. And there are multiple ways in which we can get that. We can use that. For example, here we have the city. So remember, this is quite interesting. The country for which we have the most observations is the US. the city for which we have, I believe, the most observations, I think is not the city, sorry, the market in which we have the most observations, I believe is New York. Now, the city for which we have more listings at is actually the greater city of London. So that's that actually, like, I found it surprising. So it's quite nice. If you want to select that particular element out of a computation, or out of a Panda series, because right now this is a tiny Panda series of just one element, you can use the that item at the end of it to select it. Or if the index is 0, you can also use the square brackets and then add a 0 to it. All right, so I'm gonna go ahead and leave that exercise to you. We have plenty of others in the upcoming notebooks. So let's go ahead and continue to the next one. The min and the max and the range, those are self-explanatory. The maximum value of and the minimum value of the price column, the difference of the two will be the range that we have in the dataset. So notice here that instead of calling compute in both of these, I'm actually doing a lazy computation here and here, and then in the parentheses, I'm wrapping this other computation and then calling compute on both, as opposed to compute in each one of them individually. So reducing the time to 1. And notice this. This is quite interesting. So we have a listing that costs $97,000 per night. So that seems ridiculously high, and I don't know, that just doesn't seem right. So let's do something. Let's take that price range and let's put it here. Let's take 10 less than that price range, and let's filter out. If you have used Pandas before, this operation is not new to you. If you have not used it before, what happens is that when you broadcast a Panda series or to a Panda series, when you say is something greater than X or something less than Y, then it returns to you an array of trues and falses, or an array of booleans, and you can use that to filter your data frame. So to give you a quick example, if I have a Panda series of 1, 2, 3, 4, 5, 6. So that's a Panda series. And I want to know which value is greater than 3. Then it will return false, 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 true, true, true. So here we're saying, in that same note, we're saying for the price column, I want to select only the ones that are greater than this awfully high price minus 10, so that I can select that price and see what we have. So notice we have one observation. And remember from above that we can take that item from it to just select that. So we're going to select that link, the URL that is compressed over there. And then we're going to use the panel module that we imported above. We're going to talk more about panel in the next section, because that is the tool that we're using to build our dashboard. So we're going to use the JPEG module for the JPEG function from the image submodule of the panes of panel. And we're going to visualize that item. And that does not, if you ask me, that does not look like a $97,000 listing. So yeah, don't lie to me, please. That's what I would say to that person. So there are instances where it is very important. This is something that you can find out through exploratory data analysis. Do we have outliers in the data? Do we need to deal with them? So in the next one, we will deal with outliers before we do other statistical calculations, okay? All right, so the standard deviation is very, very important. The standard deviation tells us it's a measure of dispersion. How spread out is our data from the most common value? So if throughout an entire year, the average temperature is, I gotta say this in Fahrenheit. I lived in the US and I was in Fahrenheit, so now I'm in Celsius again. So if I say the average temperature in a year is 80 degrees Fahrenheit, well, tomorrow I can be somewhat certain or somewhat, I don't know, confident that it will be close to 80%. If the standard deviation of that array of 365 values of average temperatures is very high, say 20 degrees, then it could be anywhere. from 80 degrees plus 20 and 80 degrees minus 20. So the standard deviation is a measure of dispersion. And in DAsk, we can calculate this and use it to help us answer very meaningful questions about our data. We can do so by selecting the numerical column that we're interested in and calling std, and then calling compute, of course. Then we can also use, in the same way in which we use Dask array.median, we can use Dask array std and select. Remember that we need to convert that Dask series into a Dask array to then compress it down to a single value, also called a scalar. So if a value, so we're going to have a mean, we're going to have the most common value in the middle if our the distribution of our data is normally distributed. If it isn't, but if it is, then one standard deviation away will be the median plus the number that we get in the standard deviation. So here I put the formula, but I don't think it's necessary to look at it, to be fair. So remember, the average price in our data set was about $150. That was in Amsterdam. So it was also 80 if you think about it from the perspective of the entire data frame. So let's print it here again. So about 148. Now, if we take the standard deviation, it says that it's about 438. Now, here's the question. If the average price in our data set is it's about 150 US dollars per night, and we cannot spend, we're planning a trip, we cannot spend more than $400 per night on the vacation we want to take, within how many standard deviations of the mean is our maximum price, the maximum price from that we're willing to pay in any given market? So we want to know, are we within one standard deviation? Is our maximum price within one standard deviation? Or is it within, or is it not? Or is it above one standard deviation away from the mean? So we can do that with, so we first need to, sorry, we don't need to do anything. Here is what we have. We have 438, and our maximum price is 400 per night. So we are within one standard deviation. Our maximum price, the maximum amount of money that we're willing to pay per night on a listing is $400, is within one standard deviation away from the mean of our data set. So here are the other two ways of calculating them, as I mentioned above. And then I'm going to leave this exercise to you. The variance tells us how much variation to expect within an array. I know we have about 2 more minutes before going into a break, so I'm going to maybe take 5 more and finish the notebook since we're so close to it. But to put it into perspective, the variance is tells us how much variation we're expecting in from a data set. And I think it's much easier to explain it with an example. So imagine that we have, say we have 2 groups, 5 professional athletes. We ask each of them, how much do you spend eating out each week? And then we calculate the average of those amounts. So we have 2 groups, tennis players, Serena Williams, Rafael Nadal, Maria Sharapova, and then we have 5 soccer players. And notice that the average value of all of my tennis players per week is 570. So the average of all 5 is going to be 570. If you were to ask me tomorrow, hey, how much do you think Serena Williams or Roger Federer are going to spend next week eating out? I would tell you with 100% certainty, at least to me, that they're going to spend 570 next week. But in the soccer players scenario, if you ask me, oh, how much is Hope Solo or Cristiano Ronaldo going to spend next week? I would tell you that I have no idea, given that data set, because the variation is very, very high. In one, we have 570. In the other one, not so much. And sometimes the tricky business with the variance is that it can be such a large number that it can be a little bit difficult to interpret. But nonetheless, it is a good way of understanding whether we can expect a wide variation in the next observation that we see or not in our data. Okay, very similar to the one above with that bar, and then compressing that or converting that array into, that Pandas, that Dask series into a Dask array, and then compressing it down to a single number. So very similar to the standard deviation. Here we have it. Here our question is, we've been told that hosts can change their prices as frequently as they like. So with that in mind, let's calculate the variance of the cleaning fee per market. So notice this. In some of these, in some of these markets, the variation is extremely high. You're like, okay, if tomorrow I could see anywhere from the mean to this value here, that is pretty ridiculous in Barcelona. It means that there might be quite a lot of high-end listings, just as well as there are very low-end listings or very affordable listings. Let me not call it low-end. In contrast, if you look at Hong Kong, variation of $48 per night in a listing, that's actually not that bad. So that is a little bit more interpretable, while as the other ones, they're just ridiculously high numbers, and you're like, oh, okay, maybe this is not the best measure that I should use to base my decision on or to inform my decision of where to stay. So what about the clearing fee across all markets? So that is even worse. That is about $3,000, and it must be because we have some outliers there. Okay, so the average reviews scores accuracy. So what is the average reviews scores accuracy per market, and what kind of variations are we looking at? So notice here. Here we're saying we're going to pass in a function to map partitions. So we're going to operate in each one of the Pandas data frames. We're going to take the data, and we're going to take a numerical column. We're going to take the index, the unique index. We're going to take the mean, and then we're going to take the variation. We're going to return a Pandas data frame with 1 row, 3 columns. So this is what our function is going to do. So we can also describe the review scores accuracy and say, okay, here's how many do we have? We have on average, we have everybody gives 10, or sorry, no, the median is everybody gives 10. The median is a 6, or maybe 60% if you want to see it from 0 to 100 in percentages. So let's see what the variation of that is. So notice how what I mentioned earlier about interpretability of the variance can be a tricky business. So here we have in Amsterdam, the average review, the score for a review is 7.7, which is quite nice. But then the variation is 14, which is much larger than the value that we have. So that is quite a wide thing, and it doesn't really make much sense to analyze it, but nonetheless, it's the value that we get from it. So that's a quick thing to keep in mind. Lastly, let's see, we have about, okay, 3 more minutes. So we have 2 more concepts or 3 more concepts. All right. So I would say, let's take, yeah, we'll finish it in the, as soon as we get back. So let's go ahead and take a 15-minute break because, so we have 2 sets of 10 minutes and then 1 of 15. So we're going to take now the 1 of 15 minutes. And actually, let's do it 12 minutes and 12 minutes. So it is 7 for me. So it should be for you 2, 3, 4. Should be 4 in the afternoon. So let's go ahead and take a break until 4:21. Okay. So I'll see you everyone in 12 minutes. I'll be here if you have any questions. Okay, Ramona, you were able to get the CSVs to read in properly. Fantastic. Okay, so paste the original read CSV. Yes. So I'm actually, let me see here. Let me open up a IPython. And let me import DAsk data frame as DD. So it was DDF DD read CSV. And I'm going to paste this code. I'm trying to write it for myself so that I remember. So I put that file in the data folder. And I put it in a very weird number because I misspelled it. CSV filler. I don't know what I was trying to write there. Slash or star. That's CSV. Then remember that we want to use the block size. Oops, I a capital sin, I had two different quotation marks for that string. Block size, we're going to use it as none. List index out of range. Okay, let's go in here. CSV filler 21. DAsk tutorial. Okay, let's see. Infer compression. So let's see. Oh, I know why. I know why. I'm so sorry. I am in a different folder. I am not in one behind data. There you go. So now I have my data set, and now I have, oh, I was like, what is happening here? Okay, so there you go. So let me copy this file. So remember, the tricky business is just to know where your data is at. I opened an IPython interpreter repo, and that repo started in my home directory for this project. So before, I was in my notebooks folder, and now that I'm in my home directory, I didn't have to go back one folder. So that was my mistake there. So let me paste it here in the chat. And that is what I used. I went to the FYI on the 30% fraction, doing the group by without selecting columns, tested faster for me timer versus yes. That is such a game changer. If you're gonna use a group by and you select the columns that you needed, especially, and I'm not sure if this is the reason why. I think James might know this one better than the answer for this better than me. Because Parquet is a columnar data format, then if you are selecting a particular set of columns, and those are the ones it's reading in just to do that computation, then it makes it even faster for DAS to get that. But yeah, it's a game changer. All right. So I'm going to step out and be back in 2 minutes. I'm going to go and warm up my coffee. Hey Kyle, I see your question here, and that is a great question. So let's go to the notebook and figure it out. So I'm gonna go back up to the median one. Where did I put it? Should be close to here. I want to say, oh, this is the mode. Here's the median. Okay. So the issue with the quantiles and one single variable, I think DAsk doesn't like it. I believe it is, but here is the recommended way in which um, that I found useful, and it was this one. So we're trying to look for, let's see, trying to look for the median review score per market. Okay, so here we could use the review score rating, and then we will map to the partitions. And now we have the median review score rating here. But you don't want it this way. What you want is you want the index as the index, or um, you want the market in one column, and then you want the value in another. So one thing that you could do is, let's see, we could say, we could define a little function that get medians. And this is similar to the one that I ran below. So we now have the data. The data is, each partition is a Pandas data frame. So from that data frame, we could take MKT and take, you can do a group by if you like to. I think this one is even better, or not better. I think this one might be easier, but you don't need to use a group by if you don't have to, especially if the method is a little bit iffy with the median thing with DAsk. So one of the things that we could do is we could add a column here, which will be the one we're interested in. And we will put this column here. We will get well, actually, we don't even need to, because our markets are in the index. So we would take the index, we take the unique value, and we would take that first one. Then we would take nets for the median, data, column, median. And then we could take the item of it. Then we could return a pandas data frame where these two values are going to be rows. That's why I'm using two lists, and we will use the MKT and then the mets, and then columns. We will add MKT and mets. Okay, so now that we have that, we could take this review score out. We could take this lambda function out, and we could use the get median. I keep misspelling medians. That's what I intended to have. And then for the column, so remember, the data, we don't need to pass that argument, because the data is, if you think about classes in Python, it's sort of like self. It's going to take that data frame and it's going to do something with it. Whatever is whatever the partition holds is going to take that, and that's going to be the main argument, the first argument. So then for the column, we do specify that one, and we do the review score. Now let's see what that looks like. So now we have a data frame. And if you think about it, we could also do set index MKT. And then we will have the index right by it. So we could do either or, whichever you like. And then the last piece of the puzzle will be what were we going to use to visualize it? Okay, we can use a bar. HP plot that bar. Actually, I'm going to leave this index here so that it goes immediately to the x-axis. And let's see. So this should, okay. So there it is. So let's do, I need rotation equals 75, and let's sort it by the met. There you go. So that is the one with HP plot. So I'll copy this function. I'll put it in the chat. There it is. And I'll copy this one and I'll put it in the chat as well. Okay, so 7:23 for me. It should be about 4:23 for all of you. So let's get going again. Welcome back, everyone. All right. So we were in the skewness. So skewness is very important. A lot of statistical methods assume that your data is normally distributed, and the skewness value gives you a pretty much tells you whether your data set, whether the distribution of your variable is normally distributed or not. Normally distributed means you have a skewness of 0. A positive number means that you have a positively skewed distribution, so the little bump down here, and then a negative one means that you have a negatively skewed distribution. If that is the case, when you are about to test a hypothesis or something, then you want to rethink the kind of method that you will use. Or you want to account for that with a specific statistical methodology. So I have here the formula, but you shouldn't really pay attention to that. The most important thing we want to know is, are Airbnb prices normally distributed, or do they have a skewed distribution? Because this is very important for our purposes. So we want to know, notice that there is an awfully high number, whatever that means. We don't care. The only thing that we worry about is that, is it greater than 0 or not? So essentially a binary question, do we have a skewed distribution or not? Now, I mentioned earlier that we were going to take out those awful outliers, and we're going to do so with by taking the quantile of the price column with the 0.99 and filtering out those prices that are less than that number. And then we're going to do so in the same fashion for the ones that are very, very low. And then we're going to create a data frame 2 and then a data frame 3. Oops, I did something here. There you go. Okay, perfect. So now let's look at the skewness. Is it still high? Notice how now the loading of it is taking a little bit longer for me. It's probably because also I'm like using the streaming, and maybe my computer has been on for quite a while. Of course, like it's a lot of things happening, but also these two operations take quite a while, and they will compute once we call compute. So notice that here, this took no time because we have done lazy evaluations, but here we are actually computing the quantile of the price column for the 99th percentile and the 0.01 percentile. So remember that for the median or for a quantile, DAsk needs to do a pass over all of the partitions. So it takes a little bit longer to compute that. So while we wait for that one, we'll come back to it. Let's talk about correlation. Correlation is a statistic or a methodology to figure out whether there is a relationship between two quantitative variables. So it is a measure of how strongly related two variables are with one another. And there are ways in which you can actually test this, and the most common test is the Pearson correlation coefficient, and it tells you whether it is significant, the correlation of two variables or not. We usually don't care about it. We want to, or not usually, we do care about it, but we also, when we are doing exploratory work, we usually want to see the relationship between a variable by a scatter plot, because they are pretty, they are nice to figure out, and so forth. So notice here that before we took the outliers, the skewness of our price variable was 44, and actually here I used df, the first df. So I computed the skewness on the very first data frame that we had. Now I did it on the second one, we were still pretty much the same. Now the skewness after taking the outliers is still 14, so it's still pretty high. So we do have a skew price variable. Now, the correlation, I want to point something out. The fact that a correlation is not positive, the fact that a correlation is not negative, or the fact that there doesn't mean that there is no correlation whatsoever. It could be that the correlation between two variables is non-linear as well, but I didn't put that one here because that's not the one that we see with a line, and that helps us understand whether there is something going up when something else goes up, or something going down when something else goes down. So the way to interpret it is that it is a value from -1 to 1, where 1 means positively correlated with one another, -1 negatively correlated with one another. The formula is there, but again, that does this for us. So here's the question. Is there a correlation between the increasing amount of hosts and the average prices across the years? So remember, this is a tricky one because we don't have years per se, prices per year, but we have when did a host join and what is the average price when other hosts join in that same month. So for that, we have time, we have quantity count, and we have prices. So what are we going to do for this? So we're going to do is we're going to take the date time of the host since, same as what we did earlier. Now notice, in more economic terms, this question might be posed as, are the entrance of participants pushing the price, are the entrance of new participants into the Airbnb market pushing the price of a listing up or down? And that would be a more economic way of looking at things. But so as before we did the year, and we're still doing it down here, but what we're doing here is we're taking the date attribute after converting the host since column into a date. We're taking the month, we're creating it, we're changing it as a string, and then here I'm using a lambda function to say, if that month doesn't have a 0 in front of it, put 1 in it. If not, return that same value. The reason I'm doing that is so that we have a nicely sorted array of month, year, month, year, month, year. Then what I'm doing is I'm doing the same with the year, but the years all have 4 values. So I don't need to worry about whether the month has 2 years. So for example, January will only be represented as a 1. I want it to be represented as 0, 1. March as 0, 3, and so forth. Then what I'm going to do is I'm going to create one last column. I'm going to combine the two of those, the months and the years. So actually here I put months, and this is actually a year. And this is actually the months. So if you're looking at this, change it. You don't have to. It does the exact same thing. It just didn't have the correct names on it. So we are combining months and years. So like I said, it produces the exact same result, but it's a little bit confusing if you have it as days and it's actually the year. So notice our new column, which should come up here soon. And then what we're going to do is that we're going to assign that day, month back into our data frame, number 4. Then we're going to select a, so there it is, 0, 5, 15, 12. So this is what we did earlier. We added a 0 to months that only have 1 day so that we can sort it nicely, or that DAsk can sort it nicely for us. So now we added this back into the data frame, that column. We're going to select 3 things, a market, a variable of interest, which is the host ID, when did they join, and then we're going to select the price. We're going to select a particular market, San Francisco. We're going to group by the days and month column that we just created. We're going to aggregate in the group by our variable of interest, which is the host ID. We're going to take the count of that, how many hosts join in X month. And then we're going to take the numerical variable of interest, which is the price. We could change it to the cleaning fee or to the security deposit. And we're going to take the mean of that. After that, we're going to create a little correlation matrix. And then that correlation matrix is going to tell us, okay, are these two positively correlated, negatively correlated, or do they have no correlation whatsoever? Lastly, we're going to create a scatter plot that will hopefully tell us whether one group. So here is our new group by data frame. It has the average price in that month, January of 2009, January of 2011, and so forth. And then here we have that they are, so our correlation coefficient is 25%. So they are somewhat positively correlated with one another. The price in the entrance of new markets. So that in the entrance of hosts into the Airbnb market. So what we want to do now is we want to see it in a nice scatter plot. We want to see, okay, well, show it to me. Let me see what is happening. And we're going to see more about HoloViews in the next notebook. So here we are, and now it's getting a little bit slow. So I might take a smaller fraction in the next one. So notice how we have a nice scatter plot here that shows that there's kind of a slight relationship up. So 25%, that seems like a plausible thing to think. Like, okay, this seems fair to think of this, that there's a slight correlation here. So now we're using, we want to add now what is called a slope. We want to see, so remember here we created a scatter object. HoloViews has a very nice functionality that you can take a scatter plot object that you have created, and it will compute for you the slope. In other words, the line of best fit if we were testing if we were creating a linear model. So let's see what that looks like. And then I'm going to leave the exercise to you for later because we have, I also left for you at the very end 14 additional questions that you could answer on your own with what has been explained in the entire notebook. So that's also in addition to the exercises that we have not covered. So still thinking over here. And then lastly, we're going to talk about distributions. So I'll come back here. I'll come back to the scatter plots in a second. So for the distributions, some of the things that we want to keep in mind is that there are many ways in which we can observe our distributions, and some are more useful than others. I would argue, so here I put a couple. One of the most useful ones is the ECDF, or the empirical cumulative distribution functions. They allow us to see, they essentially squash our data between two numbers, between a percentage. So how often do I see, and we'll see it in a second, how often do I see X amount of my data? How often do I see X amount of this other data? In the Y-axis, you have that percentage. In the X-axis, you have the distribution of values. The box plots, or box and whiskers, are a little box that has the maximum value in a little box with two whiskers, what is called the whiskers. And in the box, you have the 75th percentile on one side, the 25th percentile, and then in the inside, you have the interquartile. The median price will be, or the median value will be aligned in that box. And then you have two whiskers. Those two whiskers will go to the maximum value and to the minimum value. And by the way, here is our line of best fit to the scatter plot from before. So this is the correlation between the number of hosts and the average price per listing. And as you can see, here we saw that it was 25% correlated with each other. That does seem a plausible thing to believe. Now, remember, this is per the entirety of the listings that we have in our data set, which is 41 markets. This could be a little bit different if in a different situation. Yes, I believe you can get the error bands. I cannot remember off the top of my head, but you can use you can use HB that actually help, and it will tell you all of the options that you have for which are plenty. And I think it's here. I just cannot remember off the top of my head which one is it to add the bands, but yes, you can. Okay, so the next one is after the box plots, you also have histograms. Histograms are your typical distribution plot, but it has a parameter, and that parameter can be tricky to set, and it's the bins. How do we want a bin? So you have two things. You have bins, and then you have quantities. You have bins that tell you, okay, I have this edge and this other edge. How many observations fit into the values assigned to these two edges? And then you bin them. So the tricky thing is that it can be a little bit misleading or not as easy to figure out what the right amount of bins should be. And then lastly, there's the KDE or kernel density estimation. It tells you whether you are seeing a value across a distribution. It tells you what will be the probability of seeing a value at a particular spot of that distribution. So let's select a couple of columns. And then let's select a market, London. Remember, we are selecting by location here. So we're saying, here's our data frame, locate by index, London. Select the numerical variable that I selected here, the categorical variable that I selected there, and give me a plot with these variables. So this might take a second because I can see my my computer getting a little bit slower. So in the next notebook, I might select a smaller fraction so that things work out a little bit faster. Let's talk about what's going to happen. So here, what we're doing is we're taking first. So we're not taking. We're looking first at the box plot, and the box plot is going to give us that little box with the interquartile in the box, and then the whiskers heading to the mean and the max. And the ECDFs, what they're doing. So let's talk about what is happening here. So the ECDF takes the unique values. So we're taking actually here we're doing something different. So remember earlier, we've been taking the major city or the index. We've been taking the value of the unique value of that index. So every partition has a city or a market, and then we're taking that value. So this is the first thing we're doing. The second one we're doing is we're sorting the column of interest that we want to get the distribution of, or the okay, here's our box plot. So the little box, so actually you get to zoom in here with the pane on the side. So say we want to see, so here what we're saying is we have cancellation policies at Airbnb, or they have cancellation policies. So luxury super strict, you got 95 days cancellation policy. If they have a cancellation policy, a strict cancellation policy, they might not refund you. That is the business. So that is why that is a little bit tricky. So here we have a super strict one, 60 days. Let's actually zoom in on that one. So notice what's happening. So here you have the whisker. This one is the minimum value of a cancellation policy, of the price of a listing with this kind of cancellation policy, a super strict one. This is so this is the 25th percentile, 75th percentile. This line in the middle is the median. This is the minimum value within 1% margin error. And then this is the maximum value with 1% above. So everything above the 99 percentile is going to be shown as a outlier, or these dots that you see here. They are above the 99th percentile of that whisker. Okay, so the ECDF, here we're sorting our column of interest. We're returning that value here. And here we are getting the range from 1 to the length of that column, and we are adding 1, and we are dividing it. So we are squashing that between two numbers, and then we are dividing that by the length of the column. So I believe this might take quite a bit to run. But I actually want to show you, it might not actually. So let's see. Hopefully it doesn't. I really want to show you the ECDF. And then at the very end, we are creating a little teeny tiny dashboard, which is what we will create in the next notebook. So like I said, if you are working from your own computer and your computer is getting a little bit slower because of the data that we are manipulating, make sure in the next one you do a smaller fraction. I have the line of code as well at the very beginning. So this is an ECDF. And as I mentioned earlier, you have the distribution squashed between two numbers from 0 to 100. So what the way to read this is about 80% of the values in this distribution, and don't pay attention to the hover, about 80% of the values of the distribution in the price variable for London, here we're looking at the market of London, are within $200 per night. Close to 90 something percent, say 97%, are around $800 per night. So that's why an ECDF is such a useful thing to do, to visualize and to actually observe, because it tells us what percentage of the data lies at X point, as opposed to the histogram which has bins. We will also look at the histogram as well. So here we have a tiny dashboard. And I say tiny dashboard because it has a widget component. And here we can select each one of the markets and see their cumulative distribution function, their ECDF. So Rio de Janeiro. So here we see that all of them have slightly similar. So now, lastly, for the histogram, we're going to take the log price and we're going to assign it back into the data frame. Then we're going to compute the price standard deviation, the log of the new standard deviation, and then we're going to have them here. We're going to display them. Then we're going to create two variables, or sorry, a couple of histograms, and in one of them we're going to put a line with the standard deviation without with a regular price, our skew distribution. In the next one, we're going to do the same, but with the log distribution. And then lastly, we're going to look at and that is the very end of this notebook. Then lastly, we're going to look at the KD, or the kernel density estimation. And then notice here that what we're doing is we're adding a vertical line at a particular point. That point, the new standard deviation, is this one here without the outliers, and the log one is this one here without the outliers. So hopefully that computes pretty easily. Let me know. That doesn't take too long. Then at the very end, we're going to visualize the tasks that we have done today, and then we're going to run to the next notebook. So I'm going to leave the summary for you to check out. Now, when we finish this notebook, what I'd like you to do is to go to the bottom of JupyterLab and click on the two icons at the end. I want you to cancel out, shut down these two kernels, these two notebooks, so that way everything any piece of data, or sorry, anything that is being held in memory will be released, and that way you can have, like, your computer can breathe a little bit. So this is taking a second, but I'm gonna go ahead and open up. Okay, so there you go. So there is one, and here we have. You can see that the distribution is very skewed, and here we have the standard deviation that we calculated from our price column in this little line over here. So I'm gonna open. Remember that we're going to notebook number 3 after this one, and we're gonna do number 2 at the very end. Okay, so I think that because this one is taking quite a bit, I'm gonna kill this process, and I'm gonna let you run it on your own. Let me see if it lets me kill it. Okay, there you go. It allowed me to stop it. So that's fine. So a quick visualization of what we have done so far. And here it is. So here's what we have done with our data frame. So I know it looks very cool to see, I don't know, to see how much um, DAsk is doing behind the scenes for us. So if you, there was a question earlier, and I think it was from Kyle, and forgive me if I'm mistaken, and it was, why don't we reassign things back? Well, we're building a computational graph, and the more we add to that graph, the more complex our visualizations become. So this is what we have done with our data frame. These are the computations that we have done, and then you have this chart with you there. So, anyways, remember to come back to this notebook and then finish up the exercises. And if also make sure you answer these questions. If you were planning a trip, see if you can get to the bottom of all of these ones. All right. So remember, kill this kernel. You can also go at the top and say restart kernel. But you don't just want to restart it. You actually want to like quit out of it. And also, I'm gonna quit out of it out of the Flash intro, and I'm gonna also kill them here. It sounds like such a bad way, but such a bad thing, but yes. So make sure you stop those two, and let's head to the dashboard ones. Okay, so I love this quote. The point of view can be a dangerous luxury when substituted for insights and understanding. So I'll let you sit on that one for a second. The learning outcomes for this one is to have a better understanding on how to build dashboards with interactive components in them. I'm going to try to give you the formula that works best for me. I don't claim that this is the best one. I think it helps me conceptualize and when I build applications and how to think about specifically a dashboard. So I hope it helps you as well. I hope you learn with this one about different data visualization techniques and how to create maps with key components in them and how to create themes for your applications. Okay, so let's get started. So we're going to use all of these packages here. The ones that you have not seen before are GeoViews here and GeoPandas here, and the element from Tiles. So Tiles allows you to select a web projection for a map from many different providers like Esri, Carto, and a couple of others that I cannot remember. All right, so we have two data sets in this one. We have a data path, the same one that we've been using from the last one, and we have the geopath, which has the external data. And that external data are GeoJSON files. And that is a special type of format to save data with geospatial attributes for them, especially polygons and points and lines. So we're going to read this one in, and then I'm going to take an even smaller sample because I really want this to not run super slow in my computer. So that will probably take about a minute or so, maybe, hopefully less. It's actually going quite fast. And let's showcase. I should have put the dashboard first before I started off. So let's showcase our dashboard. The way I want you to think, I intended this tutorial to be as much top down as possible. I think I didn't completely succeed at that one, but in this notebook in particular, we start off with the dashboard and then we start decomposing it down. So in the next cell, as soon as this fraction finishes calculating, we're gonna get a view of the dashboard, which should be in the repo. Actually, I can open it right now. Notebooks, and it should be in your notebooks, and it should be in the dashboards folder. Yes, trust that HTML file. Okay, so this is the dashboard that we're gonna build. We have worldwide analysis of Airbnb listings we have interactive components that allows us to select whether the type of the room type that we want to see, share room, private rooms, the markets that we want to select, and then the statistics that we're interested in. The statistics are split between, I believe, these numbers. These are called big. Um, so these numbers come from a book called The Big Book of Dashboards, and the authors coined the term. I believe they coined the term big ass numbers. And then if you are in a business settings, I think the name is big asset numbers or something like that. But very cleverly designed names. So they're supposed to give you a representation that anybody that goes in there just looks at it and they immediately know what is happening. Then here we have a choropleth map that shows you the neighborhood and the average price at a particular place. So here we have, here this is the Seattle, and then you have the average price for a particular suburb. Interesting that full neighborhoods are missing from the data. Yes, yes. So not all of the, unfortunately, my cleaning of the data wasn't super perfect. So some of the neighborhoods in the neighborhood column are not completely, they might have like, they're not completely matching the neighborhoods GeoJSON file provided. So when we do the join of the two, it doesn't map one-to-one, sadly. So some of them, so the best way to do so is to get the actual GeoJSON file that the governments and cities provide. That is definitely the best way to get the most accurate one. And but anyway, so yeah, so this is the mean price per night and suburb split by superhost and regular hosts. Okay, so now that this one finished, let's go ahead and continue. And then there's the same dashboard that I showed you. So what we want to do is we want to look at this dashboard. We want to look at the elements that it contains, and we want to decompose them. We want to start. We want to build them back from top to bottom. Okay, so the canvas, the first step, the canvas and the questions. Earlier, we used panel to create a little column, a little object that had two things. One, a widget, two, a column, a object. That object was the ECDF. And in the ECDF, we were selecting markets. And those markets were giving us a particular value back and changing the function, the view, the visualization dynamically. So that is, what is that canvas? That canvas that you see there, that is panel in the background. And panel has four particular panels that allow us to build these applications. One is the row, another one is the column, another one is the tabs, and another one is the grid spec. The row basically puts anything like a Nunpai array. The column puts anything like a Pandas series. And the tabs allows us to move along different tabs, along different subsets of our visualizations, if we choose to use them. The grid space is like a big NumPy matrix where you can put into each element a object, a particular object that you like. So there are three things that are very important in panel, and those are called panes, widgets, and panels. Panels are those like rows, columns, tabs, grid specs. Widgets are the thing, this is a widget. A widget is something that allows us to interact with the data. And the pane is something that holds a particular object, not necessarily a panel. A panel is what we expose, the application. A pane is a particular object. So this right here is a pane, comes from a pane. And this ones here come from a widget. And the whole mark comes from a panel. So with that in mind, here are some of the most important options for panels. And also, very important, at the top of your notebook, you have to have that extension available so that it works for you. So let's decompose that canvas. The first one, the first row is the title. And in the title, we have, this is our test title. So that is what we have in our panel. Notice that we can change the width, and we can change that blue, and we can put it brown. We can put it white. You can change it however you like. Then in the next one, we have the first row. let's show it here. So we can use the background and then put red, and then we show red in the background. Then in the second one, we have a column with our first row. So we can combine panels and panes and widgets. We can combine them all and create this complex web of multiple of them. The only tricky part with that is that it becomes a little bit trickier to adjust the width and the height of all of them. Now, in the next one, we have a row with how do prices differ across markets between regular host and superhost. That is our left-hand side visualization right here. And then in the next one, we have the maps. What does the geographic distribution of prices across markets look like? That is our right-hand side. Then the median price, the 75th percentile, and the max price, those represent our big numbers. Although we only have two, it's sort of like a visual representation of what we wanted to do. And then in the last one, we have a column putting them all together. This is our test title. This is the left-hand side. This is the right-hand side. So that's sort of the canvas. That is what we're trying to put elements in. And that is what is, that is the major abstraction of our dashboard. Okay, so the next question, the next logical question is, so, okay, so now you show us the canvas. How do we interact with it? How do you create interactivity within these elements? So in widgets, you have a ton of other useful objects, but at its core, the interpretability of an application comes in panel has three things. It has a widget, it has a function where that widget is wrapped as a decorator for, and then it has a panel. That panel takes the widget and the function, and then it showcases what we want. We already had a taste of that with the ECDF in the previous notebook, and now we're going to do so again. So the widgets have, here in the widgets, we have an int slider, but technically, if you go to the beginning of the dot, of the last dot after widgets, and you check all of the options that you have a ridiculous amount of options. You also have float slider as opposed to just an integer slider. So an integer slider shows you or allows you to create a slider for integers. So you give it an n, you give it a star, you give it a step. Here we're saying start at 0, go to 100 in steps of 1. Name it my integer widget. And here we have a little widget. This is not doing anything. This is not connected to anything. But this is, if you notice my Python kernel at the bottom, when I move it, it's sort of Python is doing a computation. So something is going to change if I attach it to something else. So here I'm using a decorator with panel pn that depends, and I'm selecting that widget that we just created, and we're selecting we're parameterizing that with there's the dependency of panel for parameterizing options or parameterizing widgets comes from a library called param. So I believe they both work very well together, and or one depends on the other. And then we are selecting that value. We are adding that as the parameter for a function. And for any value we select, we are adding 5 to it. So we're going to create this function. And then the last step, remember, widget, function, panel. So now we're adding the widget as the first item in a column and the function in the second item of the column. And notice here what's happening. So I don't know why it's showing, let me see if why it's showing like that. New console, show contextual, show log console, new console for notebook. No, which one is it? I'm not sure why is it showing. Maybe it's because I'm all zoomed in, but it's showing a little bit weird, like 22. 5 plus 17 is clearly 22, but let me see if I fix the width by, let's say, 100. Oh, there you go. Okay, cool. So it was the width. So notice how if we change it, it changes the evaluation. So 5 plus whatever number our widget selects. And that is at its core what interactivity looks like behind the scenes or in front of the scenes, whichever you prefer. So now let's take that visualization in the lower left-hand side, the connecting the dots, and then let's put it together. So what we have is a stats widget first. interacting with this visualization. So we have here all of the markets. We have the prices. So notice this, Nashville 300 on average. So remember that this is an HTML file, so it doesn't have a Python process behind the scenes. So even though you see like you can interact with it, it's not going to change anything because it doesn't have any processes underneath it, but it was just saved that way for example sake. So here is showing the mean price per night for a suburb the mean price per night for a listing in the suburb in Nashville. So here I should have changed the suburb word to market because this is actually a market, not a suburb. So the difference here in between the two is that the blue ones are superhost and the orange ones are regular host. Okay, so let's go down. So we need, as we just saw, we need a widget and we need something that selects a value. So if I uncomment this last cell here, we see that we get a widget. And that widget has as options minimum, mean, max, and standard deviation. If you're seeing the way these values are represented, you're probably thinking, oh, this is probably the output that you use in a group by operation. And that's exactly correct. Those are the outputs we use in a group by operation. We're calling this widget statistic when it shows. So you see the statistic up here. And then we say star. So the value here is very important because that is the value that is going to start up with. So we're saying start up with a mean. Okay, so in the next one, remember as before, we're going to use and forgive me for a second, I'm scrolling up over here. Okay, never mind. Okay, so here we're going to create two conditions, and then we're going to filter our data so that it takes out the outliers. Remember that earlier I mentioned that we were going to take care of the outliers. Remember, this computation is lazy because nothing has happened yet. So now we're going to group by the market, which is our index. Then we're going to group by the host, whether the host is superhost or not. We're going to take the price. We're going to aggregate the mean, the minimum, the mean, the maximum, and the standard deviation. We're going to compute that, and we're going to reset the index. Resetting the index allows us to take out a index from the index, from the rows, and then bring it into a column. So we're going to do that. And what we're going to see now is that we have, and actually let me showcase the head of the market stats. So here's what we have. If we don't use reset index, we will have market and host is superhost inside the index, and it will be a little bit more difficult to get it out of there or to use it, but it's still usable nonetheless. So here we have 4 columns: mean, max, and standard deviation. If you notice, the representation of the data is looking more and more like the one that it is in the visualization. Now what we need to put together is 2 little data sets, because remember, this is a Pandas data frame now with that lives in memory. If we look at the shape of this data frame, we notice that it has 84 rows and 6 columns. We're going to create 2 data frames now. We're going to filter for whether a host is a superhost or it's not. And now we have 2 data sets. Notice how this one only has super for superhost. Okay, so in the next one, now we're gonna turn to HoloViews. And as I mentioned earlier, HoloViews is a visualization library, data visualization library built on top of Matplotlib and Bokeh. HoloViews, there's actually, I believe, a tutorial going on SciPy for HoloViews from the creators of HoloViews. So that is definitely a must watch because this is a very good tool for data visualization. But anyways, it gives us very good level of abstraction where we separate the data, its representation, and the layers that connect those two with the options that we want to use to add to make it prettier, our plots. So here we're doing the most basic. We're creating a scatter plot between market and max. Notice how you're probably thinking, why the heck are we doing a scatter plot with categorical variables and dots? It doesn't make any sense. And you're right, it doesn't. We could have used here bars, but then bars are not as, I don't know. Anybody can use bars to represent the distance of something, but I think here, if I would have put two bars, one on top of one on top of another, it wouldn't have had the same effect as it does between 2 points. Here you know that Prague, for regular host, the average price is 176. But here you know that for regular host, for superhost, it's 250. And now you can see a bit of a distance between the two. While as with a bar, it's sort of one will have to either be overlay on top of the other as a stack bar, or and it wouldn't have the same. I think it wouldn't have the same effect, aesthetic effect. While this one conveys the exact same information, just in a much prettier way, or so I think. So now this is the bare bones one of the one that we just saw. How do we make it look like the one above? So for those visualization types, we have a lot of customization as well. And that is what we want to use, or we want to take advantage of when we use HoloViews. Here we have the scatter. We're going to pass in one of our data frames, the one with Superhost, the one with the market. We're going to pass the market as the X value, and then we're going to pass the max as the Y value. The title of this chart, or of this label is going to be Superhost. We're going to sort by the max value, and then we're going to add color. We're going to invert the axis, and we're going to add width and height to both of those. So now notice how it's looking more and more like the one above. Of course, it's still very difficult to read. You can't really see whether, like, okay, is this one in Nashville or is this one in Los Angeles? So, you can't really tell. So it's still not quite as what we need, but it's looking much better. Okay, so in the next section, now we are adding a lot of control, a lot more to our visualization. Remember that if we add a parenthesis at the beginning and an end of a couple of functions, we are chaining methods one on top of another. So I could come down here and put the sort right below the scatter, and it will have the exact same effect. So same graph, same visualization with a label in it. Now we're sorting by the mean. Now we're taking the mean. Now we're adding the same a different color, the width, the height. We're increasing the size, so you can change this number however you like. We're increasing the size. We're showing the grid behind it, and we're inverting the axis so that we have the markers on the left-hand side or on the y-axis. We're taking the toolbar out. We want to hover over the dots, and we want to be able to see what the value is, what the representation of that dot is. We don't want any labels. We want to add a title. So this one is the label for a legend. This one is the title for your chart. Completely different. So notice how now we have average price per night by market. And now the chart is looking more and more like the one we saw above. Okay, lastly, notice how we created dots 1 here. So now we can create dots 2, but for dots 2, we don't need to worry about all of the options above, because what we're going to do is overlay these two charts on top of another. And we only need the options to be set up once for a chart that is going to be overlaid with another one. So here we're only selecting the regular host, the market, the mean. We're adding the label that is going to go to the legend. The legend is the little box that goes inside a chart. And then we're just going to use 2 options for this one. We need a different color because we don't want the same color for both prices, and we need to increase the size to the same level as the other one. So notice how, remember, we didn't add any customization to this one because it's going to be part of the previous one, of the main one. And now to overlay them, all we need to do is to use that star sign. The star sign will say, okay, put dots 1 at the bottom, dots 2 at the top, overlay these 2 graphs on top of one another. And that is what we're searching for. So notice how now we arrived at the chart that we have at the top. And that is how you look. Look at a chart, you try to decompose it, start with the title. Look at the title, what are we trying to represent here? Okay, how is this representation taken from the data to the visual object? What are the encodings between one and the other? And now, remember what we talked about, the formula, widget, function, panel, widget, function, panel. So here we have the widget. Remember that we create a stats widget. We take the parameter, we allow it to change by the value. We pass it into our function. That is the only value that we're going to be changing. And remember dots one up here and dots two, literally copy those two functions, and return the object overlay on top of the other. Now, the only thing that you need to allow to change is this: stats widget, stats widget, stats widget. Also here, stats widget, and here, stats widget. So what we are doing, we're even adding the widget as it changes. We're even adding it to the title with an F string. And we're saying, if this changes, change the title of our visualization. And we're saying, overlay these two at the very end on top. So remember, there's way more explanation up here that you can go over on your own. But essentially, we create two charts. We overlay them on top of one another. We put them inside a function. And we allow it to change by the parameter we want. If we had another parameter, we could add it right here to the left, to the right, and then have it interact with another value. So here now, the last step, so remember widget function panel. Now here we have a column, and then we're going to overlay the two on top of one another. So notice here that if we change to the minimum value, now our chart changes. If we change it to the max value, now our chart changes again. Standard deviation changes again. So that is how you add interactivity. That is how you make a function work for you. And now you could technically save this, do save, and save that element and share it with someone. Or you could do that show and show it in a server. You could add it, you could have it with a parameter called that servable at the end of your panel. Servable. And you could run this notebook in a remote server and literally have it open. And you have to set up a few things of the networking shenanigans and whatnot, all of that stuff. But essentially, you can have a little app creative on your own. All right, so let's continue. I'm going to, for the sake of time, since we have about 45 minutes left, I'm going to go ahead and continue. If you need to take a break and you want to come back, what's the syntax to add another graph table on the right of the axis graph in the dashboard? We're going to get there. We're going to get there now. We're about to get there. So let's talk about the maps, because the maps are very important, very cool, and easy. I want to say it's easy to get them wrong. I don't think. I think one of the most complex things about GIS is understanding the finer details behind coordinate reference systems and the type of files that you might receive. But I think the Python community has done an excellent job at abstracting those things down to packages such as GeoPandas and so forth. So here are the two main ones. And for the sake of time, what I'll do is I'm going to continue. If you need to take a break, go ahead and take it without a worry. If you have questions when you come back from the break, like remember what happened, stop me and ask me again. But I want to make sure this gets recorded and you can come back to this in YouTube and whatnot, and then you see the full explanation, and that way you have it there. So I'm going to continue, but please take a break if you need one. So in the next one, we're going to select a market, and from that market, if you have, remember, this is a path. So wherever you put these external files at, that is where you need to redirect this path to. I have it a folder up of my notebooks in my data file in the external folder. Those are my GeoJSON files. And I'm reading in Seattle. I'm setting the index to be the neighborhood, and I am dropping the neighborhood group, which is in the axis one, which is a column. So this is what that data frame looks like. But notice if I deselect the set index, then I have a neighborhood group that I don't really care about, because this column is not in every single one of the data sets. So for our purposes, neighborhoods work well for doing the joins later on. for a map. Okay, so we're going to set the index. Notice how here we have an object called a multi-polygon. A multi-polygon is those regions of the markets. That right there is a polygon. That neighborhood, Heller Lake. So that is what a multi-polygon holds. The coordinates for every dot that represents that that polygon. So GeoPandas is pandas supercharged for geospatial analysis. So we can use GeoViews, which is built on top of HoloViews, and and other applications, and we can pass in those multi-polygons to the polygon. We don't need to specify anything if we have a geodata frame, and it will return the maps. It will return the polygons behind the city of Seattle. You can also do so. You can come here and change it for London. And you can do the same thing and then map London. So I'm going to go back. I can't remember if I have another example with Seattle, so I'm just going to leave it at Seattle, just in case. But you can change it to whatever you like. Okay, so we're back with Seattle. Yes, I did have something with that. So we have Seattle, and now we're going to select a market from. So remember, our Pandas DAS data frame is big. We're going to select that same market. We're going to select the neighborhood. We're going to select the price. We're going to look group by neighborhood and take the mean of the price and compute that. Now we have neighborhood on the left, on the index, mean value as the values. And now what we're doing is we're creating a geodata frame with the merged data frames of our main data, a country, and the geometry column of that country. And then the left, we're joining on the left on the neighborhood and on the right index. And here we have price, multi-polygon, and the neighborhoods. So remember that polygons take the merged data and it immediately selects the geometry column. You don't even need to specify. GeoPandas tries to search for that geometry column. Then you have vertical dimensions. Vertical dimensions are the overlay ones on top of the data that is in the key dimensions. The key dimensions are your X and Y coordinates. So if you go up here, you have latitude and longitude on the X and Y axis. So now a vertical dimension will be a value overlay on top of that. And so what does that mean? That means that neighborhood is going to be part of our visualization, and so is the price. So notice now how we have our choropleth map, but it doesn't really have a hover because I deselected all of the options here so that you could see what a plain map with neighborhoods and prices looks like. If we take all of these options out, now we have a different map. Of course, we got to play with the width and the height, but notice how now if we hover, we see Heller Lake, we see Wallingford, Riverview, $79 on average per listings there. And so forth. Here we see the grading of the colors. The higher the color or the more, the darker the color, the pricier the suburb or the neighborhood. Okay, lastly, I mentioned that we imported the tiles. The tiles allow us to choose from a wide variety of maps, web projection, I forgot the exact wording of it, but it allows you to select from quite a wide range of maps. And there's a lot of cool ones here, so I highly suggest that you play with them when you come back to this notebook because some of them look very, very nice. I'm selecting Carter Light here, and I'm overlaying the map above on top of that Carter Light. And here we have the same representation that we saw at the very beginning of the notebook. So now, remember, our function or our process for creating interactivity, a widget, a function, a panel. So here we're creating our widget with our markets. We are selecting the markets here above. I deselected a couple that did not play nicely with the visualization. So one of those, sadly, where SciPy should have been at, is in Austin. And Austin, I believe, has the zip codes instead of the neighborhoods, but then the GeoJSON file provided has the neighborhoods and not the zip codes. So there's a ton of stuff that we could do to make that work, but that would take an unnecessary chunk of the tutorial that wasn't necessary. So it was easier to take it out. So here we have the markets. Here we're starting with Amsterdam. We're naming this widget markets. And this is the first step. Now we have that market. Now we have our now we need our function. We need a parameter that allows us to select a market. So everything that you just saw above, reading the file, select a market from the GeoJSON data frames. Select a GeoJSON file. Group by our DAsk data frame by that market. Select the neighborhood, select the mean of the price. Create a geodata frame with the merged data of those two files above. Plot the exact same plot that we did here. Overlay it with Cartolite in a figure. And I'm using the data. So one of the coolest things about HoloViews and GeoViews is that you can wrap things around a parentheses and then relabel and add a new title. Why am I doing this? Because I am allowing the title to change by whatever market we are viewing. And that's important for our users, that's important for ourselves, that's important for anyone that sees our work. So now we created the same function that we just walked through above. And now we can choose from Amsterdam to, let's see, Barcelona. Not all of them, like I said, not all of the neighborhoods map one-to-one. But like I said, if you go to the city and you search for the particular GIS coordinates of every neighborhood in that city, and you go through the process of downloading those files, you will have a much better representation of the neighborhoods. This one is, remember, a scraped tool. We got Geneva, which only has one. Let's see, New Orleans. I think it was a very cool. I think it was, Portland has quite a few polygons. Now there's a lot of information going on in Portland. So anyways, so that is how you do that. So that's an exercise that I hope you come back and finish on your own. Then the bands. Remember that this is from the big book of dashboards, and they call it the big ass numbers, and then depending on the setting, the big angry numbers. I love that. So remember, we have panes, widgets, and panels. Another pane can be called an indicator, and it's a number. And that gives us a fun number. So we can add a title for it and a value for it. Here are some of the main parameters of numbers, which are what we're going to be using. And then here we have another font number. We can increase the font size as a string and the title size as a string as well. We can add a default color, brown. And then we can play with those parameters. So here's another one. We can also add a format to it and add a price, a dollar sign, and then say we don't want any decimal places, and we want to add a K at the very end of it. So lastly, this doesn't need to be a complex one for the numbers, but it needs to be informative for our users. So here we are saying from our DDF3, select the room type column, take the unique values from them, take the hotel out of it, because hotels are not available in all markets. We want something that is in all markets. We want to be able to select something that is available everywhere. So we have private rooms, entire home and apartment, share rooms. Remember, create a widget, create a function, put it into a panel. So we have a widget now. Let me actually show it here. So there's a widget called room types. Here we have one function. This is not the one we're going to use, but this is one function that you can use. And then that function tells you, takes a title, a value, and a color, or a selection of a color from this 5 that I provided, which are some of my favorite ones. Okay, so lastly, we have our widget. We're going to group our data. So we're going to take a market by its room type, select the price, aggregate the mean and the standard deviation, and then compute this. There you go. So we have our data selected as we need it. And then we have our function here. We're taking, so instead of passing all of those options one by one into each one of our indicators, what we're doing is we are creating global options in a dictionary. We are creating a mask that says, take the room type, select a market. So room type, market, filter, our groups data frame, select the mean and the standard deviation. And then here we are allowing the title of that main group to change by these two parameters as well. I'm a big fan of that. Let your title change with whatever values you are representing. And then we are creating our indicators. In our indicators, we are adding a value, a title, average price, and the standard deviation. The value is going to be the column, the data frame filter by these two masks. And then the mean, we're taking the item. We talked about it, that this allows you to take one element out of a series that only has one value. And then we are unpacking the global options. Unpacking two, when you see two stars in front of a value, in front of a dictionary, that means take the key, take the value, take the key, take the value, and put all of those inside this whatever function we're using. So when you see keyword arguments, that means anything here that has a key value pair, you could change it without having to explicitly name what that is. Okay, so now we have these two, and we are returning, inside of here, we are returning a panel with the main title right over here, and a row with our two bands. We are aligning it, we are centering these two. We're giving it a width of 430, and we're centering the column, and we're centering the row inside that column. Remember how I mentioned earlier that we can combine, mix and match this? So we are combining all of those. Okay, so now we have our prices changing. So the standard deviation changing here. Let's change it for an entire apartment. And notice how our title is changing as well. Rio de Janeiro. So a share room in Rio de Janeiro. Yeah. So that's what I was just mentioning, that if you had keyword arguments, you can add any pair of any key value pair. So for example, I could add in this function, I could add a default color and add a new color without explicitly saying so, by adding that parameter there. So that's just a convention when you can do more things to a function, but you don't want to explicitly name the parameters in the function. So we don't need to use it. It's not really being used. It could be used. That is what it means. This could be of use to you. I'm gonna leave the exercise for the bands to you to make sure that this gets recorded. Then the last piece of the puzzle before we put it all together is the title. So remember, we have panes. So we have a pane that is a markdown file. That markdown file, we can put a hash to represent a title. So just like with Jupyter Notebook, if we have a markdown cell at the top and we put a hash sign, this is a title. So now we have a title. So this is the same with panes, and we're gonna use that for our title. So we can use styling, sizing mode, and margin. So here we're adding into the style a color. We're adding width, and then here we're stretching the mode. We are building them one by one so that you can see what they look like. So here we're building a last one. We're adding the margin. The margin says take it away from the top, from the corner. So I believe it's up, left, down, and right. But I could be wrong on this margin. But that's what the four numbers represent. You can go and read about it in the help with the help function of panel. We're adding a sizing mode and saying, if this application gets stretched or widened, stretch with it. So that's what the sizing mode means, a stretch with it. So now we had, if you notice at the very top, we had two icons. We had a couple of pictures, a couple of images. So this is one of the ones we had because listings, Airbnb, houses, and whatnot, but we need to make it smaller. So what we can do for that is we can use the height. We can select the height, adjust the sizing mode to be fixed. Fixed means respect this. That's literally what fixed means. Respect the sizing mode that I selected. We align it to the center, and now we have a different, look at that tiny house over there. Looks much better. We're gonna do the same with another picture that I selected from the internet, from a little GIF from Airbnb that I found. So we have that second one, and then we have a row when we have both of them. If we want to add a space in between the two because we feel that they are very tied together, we can use panel.spacer. And now we have a little space in between. We can add the width to that spacer, and then we can separate them even more if that is of your choosing. And now for the final thing, we have our header, we have a spacer, we have the two images, we have a background color, sizing mode, we want it to be fixed, and we want a width and a height. This is very important, this last part. You want the width of everything else that encapsulates your dashboard. You want it to be the same. So if you have a smaller component inside a panel, you want those small components to add up to the maximum width of your final dashboard, because otherwise your figures are going to be spilling out. And this takes a while to get the hang of. I particularly personally took me quite a bit to like play with the width and the height. It's not a complex problem. It's changing a number, but just sometimes like thinking about it, I had to take a pen and paper and draw a rectangle and say, okay, this, and draw the figures as boxes inside that piece of paper, and then start, okay, this one has 400, this one has 300, this one has 700, voila. And then, so it takes a little bit to put all that together, but it's not a complex process, at least that part of it. Okay, so lastly, so we have in our first row, what we have is the widgets. So remember, we're gonna go all the way back up to our dashboard. And remember that, so this title is the one that we just created. Then the first row, so our dashboard, now you can tell it's a combination of elements in a column. So the first row is the widgets. The second row is a figure and a column with two elements, the bands and the maps. So that is why I named this one R1. Here it is, R1, because it's the first row. Then the second one is C2. Notice how here we have the band smalls and the get map functions that we created before. Here we have all of our three widgets. So notice that is one of the elements, one of the columns. And then here we have the last one, which is the row that has my dots, has spacer in between this one and the other one, this one above, C2, and then the sizing mode is fixed, align center. Remember this, the width, it has to be the same when you have a big element. So notice how here, I didn't assign a width because that's an element inside the bigger row. So I gotta make sure you keep those in mind, because just the width and the height can give you such a headache. Like I said, it's not a complex problem. You're literally just changing a number and then seeing a visual representation and trying to adapt it to what you need. But sometimes it takes quite a bit of juggling. Oh my God, the width. How do I put it so that it works nicely for me? Lastly, so we have our dashboard. So remember, the widget follows a process. So the interactivity follows a process. Widget, function, panel. So now if we play with this and we say, give me San Francisco. So now it changed to San Francisco. Give me Oslo, Norway. Notice how it changed here. Share room in Oslo, the average price is 79. The standard deviation is 39. But then we can see the markets now. We can also see the neighborhoods. So this is pretty cool. Then we can go to the share rooms and say, okay, show me the price per night, per suburbs. I think it should come here. Share room. Oh no, actually, this one is here. Share room is here. Minimum, mean, and max is the one that moves this one. So standard deviation, so forth. So now, if we want to save it, remember you can use that save and add a name to it. This is the one we saved earlier. And if you want to show it or serve it, you can use the dash show, and it will give you a local host. And now we have our dashboard in a bit of a website. So there you have it. So there's that. Now, lastly, to make it look like the one above, it's still not complete. We still need a theme. And then that theme, we can use bouquet, that from bouquet, that theme, import theme. There's a lot of themes in there. So we are saying, change the attributes of my figure with the background color of what I selected here, with the border fill of what I selected here, with the outline color of what I selected here. Change the grid to these parameters, change the axis to this color, change the title to this color. So if we use this one, we apply the theme to the global, to our global session, And now we show the dashboard again. Let me leave it open so that you can see this one. Notice the difference now. Now we have a completely different one, and now the background we have essentially changed to like, I don't know, a more visually appealing dashboard. If I could right now, one thing that I forgot when I was creating this was, okay, I should have changed the color so that it would match the ones in the background, and then it will look a little bit more visually appealing. But if we change this one, notice the difference between the two. It's a little bit better, it merges better with the background, and it looks a little bit more appealing. So that is the dashboard. We have about 23 minutes left. Again, if you need a break, please take one, step out, you know, uh, and then come back and ask me any questions. Stop me at any point. I'll also be hanging out on the Slack later on. So any questions that you have, please feel free to throw them at me. Lastly, we can evaluate what we have done. Let me see if there is a. Oh, it's not a 4, it's only 3. So let's see what we have done here. So notice our new representation of the things that we have done to our data frame in this notebook. The previous one was pretty cool. This one is also kind of cool as well. A lot of things going on in DAsk. And it's pretty awesome that you get to assign a computation and, worry about it later, and not be bogged down because the size of the data is making your computer messed up. So, okay, with that in mind, let's close out this one, and then we're going to head up to the last one, which is the statistical modeling one. And in that one as well, we're also creating a little app to showcase a machine learning model. So I hope if we get to that part to demystify the difficulties of, I mean, putting a model into production is very difficult. The engineering process behind it is a complex step. To create something that adds value to you, that is a minimum viable product to yourself, I don't think that is that difficult. That there are tools right now that helps us do this much better. But the process of putting something into production, especially that affects a lot of people or that helps a lot of people in one way or another, that is a completely different beast. So let's go to 02, modeling. And don't forget to turn off or to shut down dashboards, the number 3. Eric, the first dashboard, the reason why it did not respond is because it was an HTML file. I was just pulling in that HTML, the saved object for showing you what we wanted to create. But I mentioned that it had no interactivity whatsoever because it was an HTML file. So it was just like, yes, you could interact with the widgets, but nothing was going to happen because it didn't have a Python process behind it. That was only for example's sake, the original one. Okay, so now we are on the second one. So I love this quote, not everything that can be counted counts, and not everything that counts can be counted. So sort of like one of those good metaphors or quotes to listen to before you dive into a particular topic that involves statistics or whatnot. So anyways, so by the end of this notebook, I hope you have a better understanding of the differences between machine learning and statistics. That is my main goal on this one. Learn how to run regressions over partitions of large datasets and groups of datasets. Learn how to take a model and create a quick and dirty application to show your work. So remember, like I mentioned, the process of putting a model into production it's a very heavy engineering task. The process of putting something that adds value to yourself and that gives you a minimum viable product, I think you should strive to show, or that's what I tell my students, you should strive to showcase that as fast as possible and then iterate backwards from that. If your process is predicting something that is not affecting anyone's lives, the difference between 85% accuracy and 90% accuracy and shouldn't be the reason why you don't have it up and running and seeing what it does. Okay, so a better understanding of what spatial regression is and how to use it. I do have an example at the very end. I don't have much wording on it, so I hope I get to it so that I can give you the proper explanation of it. Excuse me. So, okay. So let's load up our packages. Same data set from the same file. I am going to use the same fraction that I used in the previous one, which I think it was 0.08, and persist that. So the main two differences, statistics and ML. Statistics draws population inferences from a sample, and machine learning finds generalized or predictive patterns. The difference between the two is that, or one of the main, and maybe we'll go into the differences now, but if you think about it, in machine learning, we're trying to optimize something. We're trying to optimize the prediction of something. We're trying to optimize the decision of something and so forth. In statistics, when we do a statistical model, we're trying to figure out the relationship between the dependent variable, the target variable, and whatever predictors we have. We're trying to see if this statistical model gives us a bit of explanation into the underlying process that created this function or created this value. So the two are not the same, but that doesn't mean that you cannot do predictions with statistical modeling. You certainly can, but you are not splitting your data. You are not doing the same things that you're doing in machine learning to optimize that prediction, because the prediction is the goal of one, but not necessarily the goal of the other. Okay, another very good one, and I forgot to put. Oh no, I did put the article where I found this one, and I'm sorry I didn't put the name of the author. I promise I'm going to put it over there because that is not my quote. And so, statistics is the mathematical study of data. You cannot do statistics unless you have data. A statistical model is a model for the data that is used either to infer something about the relationships within the data or to create a model that is able to predict future values. Often these two go hand by hand. Now, the main differences. So statistics can make predictions, but their forte is not necessarily their accuracy. It's just the relationship between the target variable, or not just, it's one of the things is the relationship between the target variable and the independent variables. MLMs, short for machine learning models, optimize for predictive accuracy, which can lead to less interpretability. Statistical models use the entire data to find the best fit and make an inference test, or test a hypothesis. Machine learning models are trained on a subset of the data and validated with another unseen one to the model. Statistical models seek to characterize the relationship between the data, the independent variables, and the outcome variables. And machine learning models seek to optimize the prediction of future outcomes. And I think I repeated a couple over here just because it was worth repeating, but and machine learning models are not exactly a characterization of the target variable given the data. Good predictions, are better in machine learning lingo than does it make sense to a certain extent? Not necessarily, but that's why I put the dollar signs on one and the other. I'll leave it to you to interpret what the dollar signs mean. Regressors and linear regression are not the same thing. And there's a fine difference between the two. So, anyways, here are two excellent articles, papers, posts from which I learned a lot of the ideas above. So, hypothesis testing. I can't believe schools are still teaching kids about the null hypothesis. I remember reading a big study that conclusively disproved it years ago. So I hope it takes a second for that one to sink in, but it's quite funny and engaging. I think it came from XKCD, the very clever one. So hypothesis. A hypothesis is a question, a premise, a claim, or an idea that we want to test using data. Usually, the way a hypothesis goes is that we have something that is the status quo. We have something that we want to disprove, something that we feel like, okay, this is true because it hasn't been contested yet. This is true because nobody has argued against this. But is there something better? And can we prove that this is better? Can we reject the null hypothesis, the status quo? And that is usually what we're trying to do. And in statistics or in statistical parlor, the null hypothesis is expressed as H of naught. and it's the idea that you want to disprove. You can think, then H of A is the alternative hypothesis. It's the thing that we want to prove true. Then if we fail to, we don't say this is false, this is true. We don't say this this doesn't exist, this exists. We say we reject the null hypothesis if we validated our results the way we expected. If we don't, we say we fail to reject the null hypothesis. So essentially telling the null hypothesis you can continue being the status quo. We have to say a level of confidence. How confident do we want to be that we can reject this null hypothesis? Usually in science, you usually see the 95% confidence interval. And then the alpha is the level of significance of our decision. How much are we willing to tolerate? How much error? 5%. Usually, if you pick a 95, then an alpha is 5, then 1 minus 90, 1 minus 5 gives you the 95. So the p-value, which is very controversial, and rightly so, is the probability that a result we get from the hypothesis is as extreme, as we would have seen at random. And essentially, a p-value, if it is greater than your alpha, 0.5, we fail to reject the null hypothesis. If it is less than alpha, we reject the null hypothesis. So we get it our way if it's less. So always think about it. If you set the null hypothesis, if you set your level at 5%, think about it as, okay, anything below this, I win, kind of like I win, you lose, so to speak. But anyways, statistical significance is that measure, the measure plays where we draw the line to be able to say that our results are strong enough to disprove what is currently accepted. So the formal definition of it, of p-value, the probability of obtaining a sample more extreme than the ones observed in your data, assuming that the null hypothesis is true. There are different hypothesis tests. Some of them we're interested in whether a value is greater than another. In some, we're interested in whether a value is less than another. In the most common one, we're interested in whether two values are equal to one another or not equal to one another, or within a specific range, or so forth. Testing options, given the data, sample versus known population, very important distinctions. Categorical, you have a binomial test. Sample versus known populations, you have a numerical test, a one sample t-test. Samples, categorical, you have chi-square. Two samples, numerical, you have two sample t-test. More than two, categorical, chi-square. More than two numerical variables, you do an ANOVA and or a Tukey test to prove that. So another way of reframing a hypothesis, what is the probability that the difference that I am observing is due to chance? And that is sort of the main takeaway of it. What is the probability that the difference that I am observing is due to chance? Okay, last bit of talking before we get started. So what do you mean? This is the first statistical test that we're going to do. We're going to do a t-test. We're going to try to compare the means of two categories, the mean price of two categories. What are those categories? Those categories are the host versus superhost. The mean price charged by both is very similar, but are they significantly different than one another? And if so, how can we prove this? How can we test this? Let's set our hypothesis. So first, what is a t-test? A t-test is the statistical test that is used to compare the means of two groups. I'll leave it at that. There are two important types of t-test. Student t-test assumes that there's a variation, that the variation between the two groups that we want to prove, that we want to compare, are equal to each other. And the Welsh t-test assumes that the variance of both means that they are not the same. So how do we test this? Well, we need to figure out first if the variances of both groups are equal or not, to then be able to pick a particular t-test. So the step one is, first off, here's our question. What is the average, what did I have here? The average price charged by a superhost is that is what I tried to have there, is the average price, forgive the typo. Where are you? Is the average price, oh, here it is. Okay, so is the average price charged by a superhost the same as that charged by a regular host? So this is our hypothesis. Step one, state your hypothesis. Step two, check whether the variances are equal using this particular test, the Brown-Forsyth test. If enough evidence exists and the variances are not equal, proceed with the Welsh test. If not, proceed with the student t-test. Step three, pick the appropriate test. Step four, analyze the results. So this example, I borrowed it from the excellent book called Data Science with Python and Dask by Jesse C. Daniel. I highly recommend it. Of course, it is adapted to our use case, but I saw it first implemented in Dask there. Here is a few of the definitions of what we need. So we need n, the number of observations. We need p, the number of groups. In this case, 2. We need nj, which is the number of observations in group J. So number of observations in the superhost. We need the mean of so the median of the group J, the median of the superhost. We need the mean of the group J. Oh, I think I meant to put here and I as opposed to J. But yeah, one group is I, the other group is J, because we're trying to compare superhost versus non-superhost. So then we have the first step is our left-hand side of the equation, which is the degrees of freedom. What is the title of that book? So the title is right here. You see it in quotation marks over there? Data Science with Python and Dask by Jesse C. Daniel. Excellent book. Okay, so the first thing is we're gonna get rid of our outliers again, because they are ridiculous and some of them don't make sense, as we saw earlier. Remember that our price, if our distribution wasn't skewed, then we will most likely not have even thought of, we'll have skipped a couple of steps, but we know that this is just a reminder, like remember, we don't have a normally distributed price column. So just double checking, remember this is a random sample from all of our partitions. So what that means is that it's a little bit different than the previous one. The previous one said 14, but they're pretty much telling us that, yes, we have a very skewed distribution. Okay, so first we need n. We're gonna get the count of the price column. Then we need, how many groups do we have? We know we have 2, but we're doing it here in a programmatic way. We're selecting from the data frame the column host to superhost, and we're taking the unique values, and we're computing on that. Then we're calculating the left-hand side of the equation. Remember, n, the number of observations, minus p, the number of groups to superhost versus non-superhost, divided by superhost, the number of groups, superhost and non-superhost, minus 1. And this is the right-hand side of our equation. We have about 5 minutes left, and so if you have any questions whatsoever, please don't hesitate to ask. I know there's a couple of other events going on after this one and so forth. So please feel free to jump out if you need to go. If you have another one you want to go to, I'll continue for about 5 more minutes. Yeah. So the next thing we're going to do is we're going to split our data sets between superhost and regular host. And remember that we need to get the median of each one of our groups. And the way we do so in Dask is with the quantile method. So let's get those. So we have 155 for the median of superhost and 160 for the median of regular host. They seem awfully similar. Then we're going to create a function where we take the absolute deviations from the mean. We take a row from a column, the superhost column. If it is equal to true, we're going to subtract those values from the median that we just calculated, the median for the superhost. And if not, then we're going to subtract the median of the regular host from all of the regular hosts. We're going to get the median difference, the median differences. We're going to assign that column back into our data frame. And then we're going to group by the host is a superhost, and that column that we just added, remember, we need to get the mean of that column, the mean of both groups. So after we have the mean of both groups, the mean of the median differences of both groups, as highlighted over here. Mean of the median, median minus the median of one group minus the median of another. The median differences, and then the average of those. So then what we're going to do is we're going to take the group's mean variance. So the group means minus the median differences for the group mean variation. We're going to apply that to our data frame, and we are going to assign that column back into the data frame. Lastly, we get the denominator of our column, where we take the sum of the group mean variations. So the bottom part of the right-hand side of our equation. Lastly, this is one of the coolest, or not the coolest, the most useful, or one of the most useful functions in DAsk, and it's the aggregation method. And it allows you much finer tuning of the computations that you do in a DAsk partition in all of those data frames that we have. And the way it goes is, first we're gonna take the mean of the median differences, and we're gonna call it the grand means, because we're gonna need that for our aggregation. I didn't know there are other activities today. What are they? I don't know. I don't know if there are other activities or not. To be fair, I think the time difference is right now is 9 a.m. for me here in Sydney. So I'm assuming in the US now is about 6 p.m. or just about to be 6 p.m. Okay, so we have in our data frame, so we have added a couple of columns. One is the median differences, so the difference of the mean of the groups. And then here we have the group mean variation. So we need those two columns. And then what we're going to do now is we're going to create an aggregation function, the Brown four-side aggregation. We're going to take a chunk, so a data frame. We're going to take the count of whatever column we select. In this case, we're going to select the median differences, as you can see down here. We're going to take the count of the median differences. We're going to take the sum of the median differences. Remember, this is one data frame. We're going to do it for all of them. Then in the second one, we're going to take the count and the sum, and we're going to add them up. So we're saying take for every chunk, count it and sum it, the median differences. For all of the chunks, count them all and sum them all. Lastly, take those group sum and that group count and that group sum and do the last bit of our function. Take that group count, multiply it by the sum divided by the count minus the grand means. Square that. The explanations are in the markdown cells. So I know I'm going through it a little bit fast because I want to at least complete this one before wrapping up. But essentially, we're squashing down the right-hand side to one value. We instantiate that function, and then we use the group by. We group by both of the hosts. Remember, we're testing that the two kinds of hosts have a equal variances in the prices that they charge. So here we have the median differences, and we're applying that function that we just created. Lastly, we take the numerator, the part from the top, which is the sum of the group variances. Remember the little sum over here? And now that we have the sum, we can calculate an F statistic. The F statistic is the brown left-hand side. So this is the result of that formula. The left-hand side, and then the numerator divided by the denominator gives us the F statistic. Now, we need to compare that with something to be able to determine whether we can reject the hypothesis that the variances are equal. If they are not equal, we're going to use the Welsh t-test. If they are equal, we're going to use the standard student's t-test. So the F critical, the way we interpret F critical is that it is a threshold from a distribution called F. That threshold says if this is as extreme as I would tolerate a value. And the way to compare these two is if the F statistic from our test is greater than the F critical, we get to reject the null hypothesis that the two variances are equal. And what that means is that if they are not, now we get to pick the student's not the student t-test, sorry, the Welsh t-test, and compare two independent samples. So now that we know that we get to reject the hypothesis that the variances are equal, we get to go to the very last step. So we're going to bring down from the DAsk data frame, we're going to bring down the arrays to Nunpai arrays by computing essentially the entire array. And then we're going to use we can use either from DAsk stats module, the t-test independent samples. And so this calculates the t-test for the means of two independent samples. Of course, this doc string was copied from SciPy stats t-test in. And here's the SciPy stats module, which we imported at the beginning. So we take A, Group B, whatever axis, equal variances are true. Nope. Here we have to specify that they are not. And the value we get, notice that p-value. Remember that the p-value, for us to say, are these significantly different or not, the p-value has to be less than 0.05, which is our threshold, the threshold that we pick, the level of significance. Here is 1.36 to the e minus 6, so it is less than 0.05, and the average price charged by a superhost versus the average price charged by a regular host are indeed different from each other. Okay, so I think that's it for the 4 hours, if I'm not mistaken. So, does anybody have any questions for me? I know we missed a couple of topics, which was linear regression, regression everywhere, and then I have two approaches. I had two approaches here. One is a linear regression as a statistical model, where we iterate and we try to find a local maximum or a local minimum. So we're trying to get to a point where if we rerun a regression with different parameters, we get to a spot where we don't learn anything else from it, or where we are stuck, maybe. So then here I'm explaining what the metrics are for a machine learning approach, and then here I'm explaining what those are for a statistical model. So once it says here, what's the main takeaway for those missing sessions on a high level? The key takeaway is the statistical modeling and the machine learning approach. That's a great question, by the way. The statistical modeling and the machine learning approach are different, and then they are used in different ways. When you want to create a predictive algorithm, you're trying to forecast something, you're trying to make a prediction later on for some future value, for some future data point, then your best bet might be to create a machine learning algorithm, something that you can train on many, many parameters and many, many times. If you're trying to understand the relationship of a target variable, given a set of inputs, given a set of variables, say the features that make up a house, the characteristics that make up a house, then you're most likely better off creating a statistical model and evaluating the results of how well do the combination of those variables explain the target variable. So you have a one model running to the entire in the entire stack versus another run in chunks or with one piece of the data and then evaluate it on another that he has never seen before. So the key takeaway for those sections on scene is the section number 1 of this notebook, which is statistics versus ML, some of the differences. And then there's one that I wanted to mention that is a regression with geospatial information in it. And there's an example at the very bottom, and it's using the stats module library. And what it does is what it shows is that you can increase the explainability of a model if your data contains geospatial information. This is very cool because it allows you to do things that maybe you have never done before. And so let me see if I can actually run the results, and then you guys come back, and then I can explain it a little bit. And then there's also a little application. So let's see, this might take a second, but let's see what comes through. So notice here, we are training the first model. So let me walk through it very quickly. We are importing our from our machine learning libraries, our algorithm, the linear regression, the train test split, which is also available in scikit-learn, and then some metrics. We are adding a constant to our dataset that we have selected. And that dataset was created by getting a couple of dummy variables. Actually, here's the dataset. So this is the new dataset. We have neighborhood, accommodates. How many people does this listing accommodates? The bathrooms, the bedrooms, the beds, the price, room type, property type. And then we have dummy variables for the room type and the property type. And these are the ones that we're interested in. And then we are using the log price to predict the house price or the value of a listing. So here we ran an algorithm for 10 passes over the data. And then we got some statistics. Oops. So this is the little application with two models, a statistical model making predictions and a machine learning model making predictions. And it has two tabs, something that I didn't show in the dashboard section. So this is a statistical model making a prediction. If you want to say, I'm going with 10 friends to Airbnb, we need at least 2 bathrooms. We're 10 people. Actually, we need 3. We need at least 3 bathrooms. We definitely need more than 1 bedroom. We don't want to sleep on top of each other, so we're going to put at least 5. There's 5 couples. Yeah, we need 5 beds at least because there's 5 couples. And yeah, we need private rooms. Actually, we don't care if it's a house or a condominium. So this is the predicted price of a statistical model. Another approach in machine learning, say, we want to accommodate, we're a big family. I have 30 plus first cousins. So we're a big family. We're all traveling around. We need at least 10 bathrooms or something like that. We need 20 bedrooms, and we need at least 10, no, maybe 25 beds. And then we don't care, share rooms. I mean, we're all cousins, whatever. We need a townhouse. So for 36 people, we're looking at $16,000 per night. Now, this is a predictive model. I haven't explained what's behind it. I haven't shown whether we're overfitting or not. There's a lot of things that we haven't shown. But this is a way of, you have an idea, you have a hypothesis, you have something that you want to test, you have something that you're interested in. There shouldn't be anything stopping you from testing the limits of what that is. That you get to be as creative as you want when you're creating these tools. These are tools to help. These are tools to help your organization make a better decision. And if you want to create a proof of concept for yourself, I just gave you a recipe for one. This is in a local host right now. So you could put this into a EC2 instance in AWS or somewhere else, and you have a machine learning model allowing people to interact with it. And if they want to get to know what prediction they're going to use and what not, or sorry, what value are they looking at paying, given a set of inputs, allow them to change those inputs, to tweak those knobs and get a prediction back. And the way I built this, if you notice, is in the same manner as we built the previous dashboard, which is why I switched the order of the notebooks with the dashboard first, and then the statistical modeling next. So there's that. Go over it, check it out, play with it, and then evaluate what is happening. Tweak the things to your liking. So here we have a couple of different tests, and some of them are more interpretable than others. Some of them are less interpretable than others. Um, so for example, here we have mean, square, log error, and then I have the descriptions over here. But those are essentially metrics that we track to when we are trying to make a prediction. And essentially, the lower, the better. That's usually what you want. Okay, so in the statistical, to answer your question before we break it down, in a statistical model, in this one, I ran it in a subset of the data, and then I went to the other side of the data. And then in this one, I'm running a model on the entire data set. And that model, I get a very nice output. This is using stats models, OLS. And then here I'm getting a very nice output. Some of the things that we care about are, one, the R square, because it tells us how well the variation of the variation in the target variable or in the dependent variable is explained by the variation in the independent variables. So another thing that is very useful is to see, okay, which one of these variables is statistically significant? If these numbers are um, less than 0.05, which is what we picked, then these variables are significantly affecting the price that we will predict with a model from this sample or from this data. The next thing that we need to evaluate, okay, so how large is the effect and is it positive or negative? So the coefficients are what you are essentially multiplying times the new inputs. So if you have a linear model, y equals x plus b, a plus or x, a times x plus b, then that a is the coefficient, that x is the new data point, that b is the constant. What your model will provide you if all of the inputs, all of the coefficients were 0. So you need a level of understanding of your coefficients, whether they are positive or negative, and whether they are significant or not. And then you also want to know how well your model explains the variation um, in the target variable. Lastly, I also did this. I also show you here how to save the models. And then here, what we are doing, we are running the same model, but we are running it in every single partition of our data frame. So remember, the first two models, they're not going to be the greatest models ever. They're definitely not going to be. Why? Because the price in New York will probably not explain the price in Cape Town. The price in Sydney will probably not explain the price in London, or it probably won't explain the price in Miami. So the fact that we're trying to create a predictive model based on very disparate sources of information, it makes it a little bit more difficult to put together. So lastly, in this one, we can select the market. So notice here we have a model for Cape Town. And if we change the market up here to say 15, then here we have a model for Istanbul. And if we change it to, let's see, 26, here we have a model for New York. And notice this, all of the coefficients are significant. Of course, there's way more to dig deeper into it. Like this wasn't meant to be like, hey, you're gonna become a statistician. After this one, I wanted to show you how you can get started with it and how you can put something together that is useful to you and gets you a good baseline. Um, my pleasure, Brianna. Thank you very much. Michael, thank you very much for everyone. Awesome. Thank you, Tracy. Thank you, Sumida. So, anyways, the last bit of the puzzle is the spatial regression. In the spatial regression, we have the exact same thing, but here we are disable scrolling. Here we are accounting for the neighborhoods because we are assuming that some information about the price of a listing is captured by the neighborhood. So the biggest example that I can give you right now is, or the most useful example that I can give you right now is Hollywood. A listing in the area of Hollywood will not cost you the same as a listing probably in Marina Bay in Los Angeles. A listing in the Upper West Side in New York will probably not cost you the same as a listing in the Bronx. So if we assume these things are true, that there's some signal, that there's some explainability capture by the location, by the neighborhoods, then we can add this to our regression and then test and see whether that improves the model. So here we have one. I can't remember. I didn't put the. Oh, here we have Austin. So there you go. SciPy was supposed to be there. So we have a model here that explains about half. So it's half of the variation of the target variable. Of course, there's a lot of stuff that is happening here that we can probably not see that we need to tweak, but that's not the goal. The goal is to get you started thinking about these things and to get you familiarized with statistical modeling and when do you use one versus the other and how can you put this thing together and get them up and running at your organization maybe or for you to think about it. Find your data set, throw it in here and see whether you can get some interesting results out of it. So anyway, so that's it for me. If you got questions, I'll still be in the Slack channel. Let me know, run this. If you have issues with the data set, I'm sorry that there were a couple of issues at the very beginning. So thank you for working through that. And yeah, let me know. I'll be in the chat in Slack. So thank you very much for coming, everyone. James, you're still there?
Yeah, I'm still here. Great presentation.
Awesome. Oh, thank you very much. All right, James. So I guess I'll stop sharing now.